As Indra Nui said, the more we break rules, the better off we are going to be. It's a quote that is particularly apt today as we witness women who not only challenge society but also leave a mark by taking the road less traveled. Hello and welcome to the Tata Steel Women of Metal Grand Finale event. I, Urvashi Singhal, am delighted to be here as we witness spectacular ideas of innovation. Started in 2017 with the goal of identifying, grooming, and encouraging the induction of female engineers in India's manufacturing industry, Tata Steel Women of Metal has helped many bright young minds develop, own their intellect in areas of research and development, and overcome the technical challenges in the steel industry. Leading to an equitable and inclusive tomorrow, the competition has proven to be the perfect launchpad for many women leaders these last 4 years. With the same aim, the challenge came back in 2021 and observed the highest level of enthusiasm, breaking previous edition numbers. Congratulations to the very talented and intelligent finalists who have made it here. With the extremely high level of competition witnessed till now, we can say that it certainly wasn't easy this year. Having overcome many challenges, it's now time to prove your mettle not only in front of the jury, but also to everyone present in the audience. On that note, let us extend a huge round of applause and welcome our distinguished jury. Mr. D.B. Sundaramam, Vice President Raw Material, Tata Steel, and Mr. Prabhat Kumar, Principal Executive Officer Designate, Tata Steel. Hello, sir. Very good morning.
Yeah, good morning, Urvashi.
Good morning, Prabhat, sir.
Good morning, Urvashi.
So, Mr. D.V. Sundaramam is a mining engineer from NIT Rourkela, having passed out in the year 1990. He then completed his general management program from XLRI Jamshedpur in the year 1999. He holds a first-class Mine Manager's Competency Certificate in Coal from the Director General of Mine Safety, DGMS. Coming to Mr. Prabhat. Mr. Prabhat Kumar, Principal Executive Officer of Tata Steel, has 31 years of experience with Tata Steel in manufacturing, marketing and sales, and strategy formulation. He has wide experience in commercial function and has been instrumental in establishing market leadership position for Tata Steel's automotive business in India. He has wide experience in international markets and has established export markets for Tata Steel products from its new plant in Kalinganagar. He has led sustainability, circular economy initiatives in the last few years as EIC of Industrial Byproducts Division. He takes active interest in volunteering and welfare activities and has supported Center for Hearing Impaired Children and Bal Vihar as its chairman. He also likes traveling and has keen interest in sports like cricket, football, and tennis and outdoor exercise. We welcome you, sir. Okay, so before we get down to the details of what today has in store for our finalists, I would like to request our esteemed jury members to say a few words about what they are expecting from the Tata Steel Women of Metal Grand Finale and the journey that has led us all here today. Mr. Prabhat, if you can please say a few words.
Good morning and best wishes to, first of all, the talent which has come for the Women of Metal finals. So I wish them all the best. And I'm really excited to be participating in this program, more as a jury and also as a learner of the new skills which the Women of Metal and all the finalists who have come over here to showcase their projects. So I'm really looking forward to you, and thank you and best wishes.
Thank you so much, sir. Mr. Sundar?
Thank you, Urvasi. Good morning once again to all the participants. First of all, let me congratulate all 10 of you for getting into the grand finale through a fierce competition. Trust all of you and your family members are safe and healthy. So, as all of you are aware and appreciate that it's a pioneering initiative, the Women of Metal in the Indian manufacturing industry. It also helps in attracting best of the talent from the female engineering graduates from across all the primary institutes. Besides that, it also helps the aim of Tata Steel to become 25% participation of women in our overall manpower which we have. So today we are not at that juncture, but yes, our endeavor is as part of our inclusive growth as well as diversity, we would like to come to 25% of that. And I feel this is one of the best initiatives to reach out to all of you, and through you to all the female participants and the enthusiastic engineers who would like to be part of Tata Steel. I would just like to share one small data point. After the Ministry of Labor has enacted and changed the act and said that now women can work in mines, we have got women mining engineers who are working and mining all the 3 shifts. And you will be happy to note that we have got women operators. These HEMM operators in our mining palace, we call them super machines. We have got the HEMM lady operators, female operators who are running them easily, and now they are competing with the men. So this is one of the best opportunities for all of you to get associated with the Tata Steel family. I wish you all the best. And also the way I said, my congratulations to all of you as you already come into the top 10. Thank you.
Thank you so much, sir. I must say our finalists must be really encouraged to show their best in the challenge. Okay. So let us now move on to the finer details of what the students have been working on. Specially designed to induct women in the manufacturing sector, this competition covered broader aspects of solving technical challenges in the steel industry. The applicants had to work on finding possible solutions under the mentorship of experts. After passing a rigorous selection process, the top 10 finalists are here today to present their solutions in front of the jury live. Coming to the guidelines, the rules of the day. Each team will have 10 minutes to present. The first buzzer will go off at the end of 8 minutes, followed by the final buzzer at 10 minutes to indicate the end of the presentation time. Each presentation will be followed by a 5-minute question and answer session with the jury. Now that the rules and regulations are clear, let us start. So without any further ado, let me call our first finalist on stage, Aishwarya Raj from IIEST Shibpur. Hi Aishwarya, can you hear
Hello,
me?
ma'am. Yeah, yes, ma'am. So I'm going to start. Yeah, good morning, respected sir. Today, with your due permission, I'm going to give my presentation on the topic identification of various factors that impact the performance of belt wing system at TSK and coke balance MIS. Let us have a look at the flow of my presentation. First of all, we'll understand the case statement. Then we'll have a brief introduction of belt wing system. We'll see the actual performance analysis of belt weighers in coke balancing at TSK. Then we'll identify various factors that impact the performance of belt wing system. We'll also see some corrective measures and best maintenance practices, along with the recommendation of an alternate solution, and lastly, the conclusion. Let us first of all understand the problem statement. As it is a popular saying that we cannot manage what we can't measure. And in a steel making process, huge amount of bulk materials like iron ore, coal, coke, sinter need to be smoothly transported from one section to the other. In this case study, our main focus is on coke and coke balancing. Coke balancing implies to maintain a precise balance between the amount of coke sent by the dispatching section and amount received at the receiving section. But since few months, it was observed that there exists a significant gap between the amount dispatched and received. So to ensure the accuracy, we have to carefully identify various factors that are impacting the performance of our belt wing system. Now let us have a brief introduction of belt wing system. A belt wing system is an equipment that continuously measures the flow rates of the material that is being transported. In this small video, we can see that the material is being transported on the conveyor, and the load cell is continuously measuring the load of the material, and the tachometer is continuously measuring the speed of the conveyor. This is the integrator that is continuously integrating the output of load cell and the tachometer. Load cell is a force transducer, and tachometer is a speed transducer. Now, the belt wing system is broadly classified into two types: belt scale and wave feeder. Belt scale only measures the current flow rate, whereas wave feeder not only measures the current flow rate but also controls it according to the given set point. Now, let us analyze the performance of belt wing system in the coke balancing at TSK. Now, in this flow chart, we can see that the coke is being transported from various sections in the coke feed circuit of coke plant and blast furnace plant. This triangle represents that there are various belt weighers that are installed at various locations to determine the amount that is being transported in the various sections. There are balancing equations to keep in account the amount that is being transported and dispatched and received. So the monthly results of 3 months show that there existed a significant gap. Like in the month of May, the gap was about 1,861 tons. In month of June, it was about 165 tons. And in month of July, it again soared up to 2,196 tons. So they are huge amount to be ignored. Now let us see what are the factors that are affecting the performance of our belt wing system. Now, first of all, let us see how to evaluate the performance and what are the parameters. There are basically three parameters: accuracy, repeatability, and linearity. And I have classified the performance of belt wing system at TSK in broadly two categories. First is breakdown owing to component failure, and the second is low accuracy due to various factors. In the past 3 years, it was observed that the major cause of breakdown was load cell failure, followed by load cell malfunction and other minor faults. But in this case study, our main focus is on the low accuracy of belt wing system. Where the various factors are installation related, dynamics related, and environmental related. We'll see one by one each of them in details. Now, first is installation related factors. In this small video, we'll see that how the belt weighers are installed on the conveyor belt and how the carrying idlers are replaced by the weighing idlers. Now, the proper location of belt scale should be at least 12 meters before and after the tangent of the curve. Now, the second is the weighing idler misalignment. If the idlers are placed too high or too low, if they are placed too low, that a tight conveyor belt could bridge over the skin and it will go completely undetected. And if they are placed too high, it will increase the weight, it will exaggerate the weight, and load cell will measure exaggerated weight. Now, we can correct it by carefully aligning the weighing idlers. Belt tension, if the belt tension is too high or too low, it is the second most common source of inaccuracy. So the ideal belt tension is the sag of 2% between the idlers, and any deviation will lead to inaccuracy. Gravity take-up devices should be used. Now, the second are the factors that are related to dynamics of the belt conveyor. First is non-uniform material loading. It can be corrected by installing a material feed control gate. And second is the belt speed too fast. If the belt speed is too fast, it can lead to material spillage, which will lead to inefficiency and loss in productivity. And also the load cell will not get adequate time to adequate retention time to sense the changes in forces on the load cell. Now, if the proper maintenance is not there, we can see that it can lead to wear and tear of the belt, material buildup underside the belt, and erratic belt tension. So material buildup can be cleaned by using the vibrating cleaners. And now fourth one is the calibration, which is of utmost importance. Calibration should be performed on time, should be designed properly, and the method should be correct. Now, belt tracking, in the small video, we can see that with the help of belt switch and various mechanical equipments, the belt tracking can be done, and the belt can be centrally aligned. Now, the troughing angle, the maximum permissible limit of troughing angle is 20 degrees and not more than that. Now, factors related to maintenance and different calibration methods. We have standard maintenance practices at TSK which have to be followed, and which have to be followed very regularly. And I have listed several methods of calibration like static test weight calibration, chain calibration, material calibration, and electronic simulation method. So in TSK, the most common is static test weight calibration and electronic simulation. But the most accurate one is the material calibration, and it is also performed in TSK at time of requirement. Now, let us see some environmental related factors. There are various environmental related factors like large temperature variations, pressure differential, moisture, RFI and EMI, and I have also listed some of the corrective measures. These are some best maintenance practices. Most of them are already discussed, but to give them proper emphasis, I have listed them again, and should be and like calibration should be done regularly, maintenance, documentation, etc. Now let us see the recommendation, which is a better alternate solution to traditional belt scale. We saw that there are so many factors that are affecting our traditional belt scale system. So an alternate method, which is a contactless method, is recommended here. And another contact method is, it uses laser scanners, but another contact method which is being used in the industries are absorption of gamma radiation. But I feel that this is the most accurate, as there are several advantages in gamma radiation, like absorption of gamma radiation, like it is very cumbersome to handle, and it is also a hazardous sometimes use of radioactive source. So it uses laser scanners and also uses laser triangulation method. In this mod video, we can see the working of the laser scanners. First, the industrial camera accepts the images produced by a line source of laser projected on the bulk surface with the scanning frequency set to 300 Hz. This laser scanner will compare the height of the empty belt with the material that is being transported on the belt. And signal processing software system analyzes the images and uses laser triangulation method to calculate 3D contour information and volume flow rate. So it offers an accuracy of up to 99.8%, and it can, since it is contactless, so it is dynamic. It is free from dynamic related factors. It can withstand harsh condition. It is convenient for data access and can be used in Industry 4.0. And also it is maintenance free, so I feel that it is very cost effective. Now, since I already said it is non-contact, so it offers very high precision, and also since the frequency is set to 300 Hz, that also add-on point to the precision. Now let us finally see the conclusion. We saw that there are so many factors that are affecting the performance of our belt weighing system, and also how the maintenance and calibration are the key factors where we can achieve our desired accuracy. And an alternative method was also suggested, like which was contact-free laser scanning method, the flow measurement of bulk materials. And lastly, I would like to thank Tata Steel for giving me such a great opportunity, and also my mentors, Mr. Deven Kumar Shah and Mr. Subrat Das, for guiding me throughout my project. Thank you so much.
Thank you so much, Aishwarya. What a great start to this show. Your presentation has set some great benchmarks. Okay, may I please request the jury to come up on stage for the Q&A round? So you may begin with the Q&A.
Yeah, Aishwarya, very good presentation. The problem statement, and also the way it has been analyzed, and also the recommendations are really good. So only one query I have. You have mentioned that we must ensure proper loading of the belt conveyor. Unless the loading is uniform, it's very difficult to do it. So how do we ensure that proper loading is there? Number one. Number two, does this laser scanner identify that the loading on the belt conveyor is not uniform?
Sir, we can ensure uniform loading. So there are wave feeders which controls the flow rate as per the given set point. So uniform, yeah, at times it happens that there is non-uniform loading, like the speed of the material is not equal to that of the speed of the conveyor. So so as I already said, that in the corrective measure, that we can install a material feed control gate which will enforce the uniform flow of material. And also the laser scanners, as the vendors are claiming, that it gives an accuracy of about 99.8%. So so the uniform loading it still depends on the means how it is loaded, but yeah, they can scan it very efficiently, and they can scan the volume flow rate, and the density is predetermined in the system itself, which could be multiplied to give the desired result. Yes, that's all.
So what is the calibration frequency you would suggest? Because what is there currently, and what would you suggest to be more accurate?
Sir, the calibration frequency for the system is already mentioned in the standard maintenance practices, and it is very, it is said by the highly qualified people, and I think it is very it is very suitable, and it should be followed according to the SMP with no delay, and yeah, so it should be mandatory followed.
So did you find any discrepancy? Did
sir,
you find any discrepancy?
It may happen that, yes, sir, I asked from my mentor, and he said that, yeah, it sometimes happens that there is some delay in the calibration, or it happens very frequently, like zero. If they find any error, the zero calibration is done very quickly, and the electronic simulation is also done very frequently. So still, actually, sir, the topic was given according to my mentor, because there were error of about 5 to 6% or more than that in the previous time. So they reduced it with their honest efforts and their hard work. They reduced it to 1 to 2%, which is the maximum permissible error limit. So yeah, sir, that I want to say, that they are already working on it, and they are great job.
Thank you. Yeah, over to Prabhat. Sorry for consuming more time.
Yeah, hi Aishwarya, and thank you for an excellent presentation, very clear and transparent. So I just had one query. Before recommending the solution, what other options did you consider, and how did you prioritize on this solution?
Sir, actually, I studied about the contactless methods which are invented in the countries like China and Germany, and I saw that the gamma radiation absorption is already in practice here. Like my mentor said that for the audit person, the third party comes, so it uses the contactless method only, which is probably the use of gamma metric radiation. But I feel that laser scanners are not hazardous, since it does not use any radioactive source. So yes, so that's why I came to that conclusion. And since it is contactless, so I feel that any dynamic it will be free from dynamics related factors which were discussed here. So yes, sir.
Thank you for your excellent presentation. Thank you. I have nothing more.
Thank you so much, sir. Thank you.
Thank you, jury members, and well done, Aishwarya. Next, we have with us Chaya Sahu from NIT Raipur. Can we please connect to Chaya? Chaya, are you able to hear me? I feel there is some internet connectivity issue because of which we cannot connect to Chaya right now. We may try that later. Next, we have with us Deepshika Brahma from NIT Roorkela. Hi, Deepshika.
Hello, ma'am. Good morning.
Good morning. Just wait a minute. Yeah, you may start with the presentation now, Deepshika.
The advance of technologies is based on making it fit in so that we don't even notice it, and it has become a part of our everyday life. Good morning, everyone. I self Deepshika Brahma, pursuing BTech in ceramic engineering at NIT Rourkela, being inspired by the technological advances, did a case study on the topic role of carbon in refractories. So refractories are the non-metallic minerals having excellent thermal and mechanical properties which are applicable in high temperature and high load condition. Carbon refractories belong to the class of neutral refractories. In figure 1, the microstructure of carbon-based refractory comprises of carbon which is present in the matrix either as a binder or as an additive phase. In the micrograph of carbon containing refractory, carbon forms the basis of the aggregate and the binder phase. In the history of carbon containing refractories, we have seen that there had been some new additions like addition of antioxidants, addition of binding agents. The application area also improved. But from 2000 onwards, there had been some new implementations like addition of nanocarbons, submicron graphite, and also graphene addition. Flaky graphite plays a very vital role in all the carbon containing refractories, especially in the magnesia carbon refractory. In figure 4, the effect of graphite is shown. If we add graphite to the magnesia carbon refractories, flaky graphite, which is a very fine material, which fill in all these spaces, thus producing a very dense and a compact structure. Therefore, the modulus of elasticity decreases with graphite content. Thermal conductivity also improves because of the free electrons which are present in the hexagonal layers of graphite. The bulk density of the refractory reduces on addition of carbon because of the lower specific gravity of carbon. The apparent porosity also increases because carbon at a high temperature oxidizes and results in the formation of porosity, thus increasing the apparent porosity of refractory. Carbon has a non-wetting property because the contact angle is 140 degree and decreases very little with time. So if we add carbon to pure magnesia grains, the contact angle increases, non-wetting property enhances, and the depth of slag penetration decreases. Talking about binding agents and antioxidants, the list of binding agents are mentioned here, and we use the most favorable one as the phenolic resins, because phenolic resins produces phenol and not the toxic polycyclic hydrocarbons. The viscosity of phenolic resins is also very less, which ranges from 500 to 3500 millipascal at 25 degrees centigrade. Due to this lower viscosity, it results in the formation of a very dense and compact body, thus increasing the mechanical strength of the refractory. Antioxidants also have a very vital role because this oxidize faster and prevents the carbon oxidation. Tata Steel has been using aluminum and silicon metals mostly, but aluminum and boron carbide is the most favorable antioxidant combination. But boron carbide is of high cost, so Tata Steel is not using because we want production with a less cost consumption. So we are using aluminum and silicon metals. They're talking about the mechanism of aluminum here. First, aluminum reacts with oxygen to form the aluminum oxide. This aluminum oxide entraps the molten aluminum. It further reacts with the carbon to form aluminum carbide, which reduces carbon monoxide, forming aluminum oxide again. And aluminum oxide forms a spinel structure with magnesia, resulting in the closure of the porosity and increasing the mechanical strength, which is depicted in this graph. Graphitization is another one common phenomenon which is implemented in the industries because there is a huge mass loss of phenolic resins with increasing temperature. So if we add some graphite properties to it or induce some graphiting nature, we can prevent the mass loss. Graphitization are mostly accompanied by using a cross-linking agent, which is a HMTA and which is a hardener, which forms a polymeric network of resins. Ferrocene of 98% purity is also added as a catalytic agent. Boric acid is added in the laboratory experiments, but it showed a failure in the industrial experiments, because boron diffuses into the structure of the steel, corrode the steel property, and makes the steel brittle. So we are not using boric acid as an additive. The manufacturers are using some other additives like ferrocene and exfoliated graphite instead of boric acid. There are several types of carbon-containing refractories, and the application area is mostly in the blast furnace region, the tap holes, the runners, and the torpedo ladles. Application of carbon in blast furnace. Carbon is used in the form of bricks in the upper bottom, lower hearth, tuya regions, tap holes, as well as the runners, because carbon has got a thermal shock resistance property, and it can also withstand the high temperature and high load conditions. It also prevents the depth of the slag penetration, as well as the metal also cannot infiltrate into the refractory lining, and it can prevent from the corrosion. The new implementation in the lining of the runners is the PCPF blocks, which is composed of alumina, silica carbide, and carbon. If we add carbon to the backup lining of the runners, we see that it enhances the thermal shock properties, because it is not wise to replace the lining of the runners again and again, because there will be some disadvantage of changing the linings, and it can prevent the production rate also. It can affect the production rate. So we are using calcium carbon also here, because it can resist the thermal shock. Moreover, the trough castables, which is the front lining, is also composed of alumina, silica carbide, and carbon, which also has got the same property. Corrosion resistance can be prevented by a combination of aluminium and boron carbide. Here in figure 14 and 15, we see that the corrosion is also decreased by addition of this combination. Boron carbide forms a gas buffer, and aluminium forms this spinel, which has got a combining effect, and it prevents the corrosion. Another method is a slag splashing technique. If we coat the refractory lining with slag, it prevents the atmospheric oxygen to come in contact with carbon, and it prevents the carbon oxidation. In acidic slag condition, the most important reason is the saturation solubility of magnesium oxide in slag. And if we add aluminium to it, it has got no positive effect. So what we can do is we can increase the size of the magnesia grains. And in basic slag condition, aluminium addition has got some positive effect, because it prevents the oxidation of carbon by forming the spinel structure. The first series belongs to 1400 degrees centigrade investigation, and here the oxidized exterior cell is quite thicker, because carbon is directly oxidized here. And in 1600 degrees centigrade, the layers are quite thinner, because carbon is indirectly oxidized by magnesia, and the magnesia form filling the pores and prevents the oxidation. The results at 12% and 16% are quite similar, because at high percentage of carbon, the oxidation of carbon increases, and we cannot prevent that. So we use some antioxidants, which I've already said about that. The problems I have been stating beforehand also, that is the porosity increases, and there is a generation of carbon monoxide and dioxide gases. There is a huge heat loss from the wall because of the high thermal conductivity of graphite. Now coming to the most interesting part of my presentation, that is the new implementations. Tata Steel has been implementing nanocarbons in some critical use, but nanocarbon has got some inferior properties like inferior oxidation resistance. It has got some inferior thermal conductivity also. So we use some percentage of graphite, like 5 to 3% graphite along with nanocarbons, because it can prevent the depth of the slag penetration, it can reduce the porosity and improve the strength. So because the nanocarbon is of high cost, it is still in critical use, but we can add it by using some percentage of graphite and further calculations. Expanded graphite and submicron graphite are the smaller structures or some improved structures of graphite. Expanded graphite is due to the thermal shock, means the interstitial metals are exposed to the thermal shock and it volatilizes, results in the expansion of the lattice structure. So expanded and submicron graphite are smaller in size. It fills in the pores properly, preventing the carbon oxidation and increasing the cold crushing strength of the refractory, which can withstand the high load. Talking about graphene and graphene oxide nanosheets, Tata Steel has been producing graphene, but it is not implementing graphene in the refractory lining because of its high cost only. Moreover, the transportation cost will also be increased because these are mostly produced in European and Japanese countries. I have studied that graphene and graphene oxide nanosheets also have some limitations in the manufacturing technique, but these additions can improve the thermal shock property, and it can also enhance the slag resistance property. So I guess extensive research is needed in this area, because I could not find many literature reviews review papers on this, and some industrial experiments should also be done. So these are the information these are all the sources from which I have collected the information. I thank my mentor and Tata Steel's team for providing me this wonderful platform. Thank you so much.
Yeah, thank you, Deepshika. So definitely, it's a topic that requires more time also and more research. I would like to have only one query. So you said the graphene oxide and graphene oxide nanosheets are also one of the alternatives for this carbon. But have you done any other study apart from these? What else could be? Because you mentioned the disadvantages of using only carbon. Then you also said, yes, graphene oxide also has got some disadvantages. You talked about nanocarbon also. So which one we can, going forward, we can practically use and also minimize the disadvantage? Each one has got its own advantage and disadvantage. Yes. But going by your study, which one would you recommend?
So I would recommend the graphene oxide nanosheets because these are quite the pure form of the graphene structure. It also results in the formation of ceramic whiskers, that is smaller ceramic particles in the interstitial or in the interlattice structures. So these ceramic whiskers are highly reactive at a lower temperature and flaky graphite do not react much, and it has got a lower reactivity as compared to the ceramic whiskers. Although the cost effect is more in graphene, as nanocarbons, we are adding some percentage of graphite and we are using it. Similar effect can be done by using graphene oxide nanosheets, and we can add some percentage of flaky graphite to it. And we can experimentally study this new implementation.
So have you done the cost comparison also, each one of them?
No, the cost comparison, it was not quite applicable to me, so I had not done this cost comparison.
No issue. No issue. Thank you. As I mentioned, it's a difficult study as well. Yeah, over to Prabhat.
Thank you, Deepshika. Very good presentation. And I had only one small query. While recommending whatever you have suggested, what are the other parameters did you consider apart from cost or ease of implementation? So what factors did you consider?
Sir, I considered the porous nature because carbon oxidizes at a high temperature. As we have seen here that at 12 and 16% carbon, the oxidation resistance property of carbon is reducing here. So I take into this account that we should have to reduce the porosity, and we have also to improve the strength because porosity results in the weaker strength of the refractory. So if we use nanocarbons, which are smaller in size, and the submicron graphite, these are all particles are very small in size. So it will cover up the pores and it will fill up the spaces more appropriately, and it will enhance the cold crushing strength as compared to the flaky graphite, which are quite larger in size.
Thank you, and I am convinced about the solution, but I just wanted to know different parameters that you consider before arriving at the solution and saying that this is the best solution for the given problem. So that's my query.
Sir, the problems which I had discussed about with my mentor is that if you are using flaky graphite, which is quite cheap, and it has also got some good properties, then why should we replace with something which is quite appropriate in the Tata Steel projects, like in the refractory units? So she suggested me that carbon has got some disadvantage property, like it increases the pollution level also by releasing out the carbon monoxide and dioxide gases. So if we use nanocarbons or some flaky graphite or the expanded graphites one, which are quite a finer structure, it will prevent this type of condition. Like it will prevent the pollution level because it will not oxidize that much faster. It has got a higher oxidation resistance property. So this will prevent the pollution level also, and it will reduce the porosity also.
Thank you for your responses. Thank you.
Thank you, sir.
Thank you, Jury. And what a wonderful presentation, Deepshika. Wish you all the very best for the results. Okay, so we have got connected to Chaya back again. And now I would like to invite Chaya Sahu from NIT Raipur. Hi, Chaya. Good morning.
Hello. Good morning.
All set for the presentation, Shaya?
Yes, sure. Shall I begin?
Just give me a minute. Getting a bit nervous?
Not exactly. Good morning, everyone. Good morning, everyone. Respected jury members, my name is Shaya Sahu, and the topic of my presentation is Study on Effect of Variation in Input Drawing Parameters on Furnace Permeability under the guidance of Pravanjan Samantarai sir. The iron-making blast furnace process is an energy-intensive metallurgical process in terms of coke, coal, and fuel consumption. But in the past few years, the focus has been shifting towards energy-efficient operation and improved production through a stable blast furnace. But due to the chemical and physical phenomena inside the furnace, which are directed by non-linearly interconnected variables, it becomes very difficult to access the life status of the furnace. And therefore, this project aims to develop a data-driven model to analyze the furnace permeability and ultimately achieve the operational goal. The blast furnace is a giant gas-solid liquid countercurrent reactor for the production of hot metal. The process starts with charging of alternate layers of coke and iron ore burden with simultaneous injection of hot dust air with moisture, oxygen, and auxiliary fuels at around 1100 to 1200 degrees centigrade via the 2 layers. The hot ascending gas, while reducing the iron oxide to iron, travels through the voids of the burden layers and escapes from the top of the furnace as top gas. During this dynamic process, the resistance to the gas faced by different bedding zones accounts for the total permeability index. And the current calculation involves the mathematical equation with hot gas pressure, top gas pressure, and wash gas volume, although it is also affected by coke-to-ore ratio, burden profile, flame temperature, and many other parameters. So in order to find out the most important parameters, we dive into the permeability analysis of the different zones. Starting with the lump zone, the degradation of sinter into fines and creation of an interfacial layer, it causes the decrease in voids and can be prevented by spraying a solution of calcium chloride and acting on the burden arrangement. With the softening and melting of ore in the cohesive zone, lowest of permeability is seen due to blocking by molten metal of the coke layer. And this can be addressed by a central coke charging methodology for central gas flow. Or coke charging method can also be deployed for the better permeability. The gang burden premature reducibility can also be tackled by using a basic sinter. Now, moving to the belly wash region, the coke is only solid material present in the zone, and its size distribution deeply impacts the permeability of the zone. Many researchers argue that due to the unlimited gasification dissolution reaction with carbon dioxide, the skeleton structure is completely destroyed and can be improved by reverting the reaction with hydrogen or water. Also, the slag retention on the coke bed causes decrease in permeability. One interesting problem was seen due to the pulverized coal injection. After increasing it by a certain value, the unburned coal car was found to accumulate in the zones of slow gas flow or changing directions. So this can be enacted by oxygen enrichment and proper draft. Now moving to the hearth region, major troubles here are due to the gas slag interface and furnace casting and skull formation. This can be prevented by low slag practices and the presence of low amounts of aluminum oxide and magnesium oxide in the slag for better fluidity and maintenance of an optimum range of hot metal temperature and viscosity. From this analysis of literature, we could see that permeability in its own is a huge complex topic, and the blowing parameter significance increases after the burden has been charged. So we move on to select the most important of the process parameters. But the hostile condition of the blast furnace do not enable us to make direct permeability calculations, and we have to rely on boundary parameters. The selected boundary parameters are here in red and were taken into account for the model preparation. The furnace data was taken, cleaned, and developed into a Pearson coefficient model to select the highly correlated parameters. A total of 12 parameters were selected, but especially including the lower, middle, and upper K values for the inclusion of the properties of burden, raw material in the model and a better accuracy level. From the previous researches, 4 Python models were found suitable and were tested for the suitability in this data set. Finally, linear regression model was selected owing to its high regression score and low RMSE score. The model was then trained and tested in Python via Jupyter Notebook, and the trends were thoroughly analyzed for each of the parameters. Positive trends were seen in case of raft, hot plus temperature, pressure, and oxygen enrichment, as their combination gives a better combustion and consumption of coke and coal, which leads to a good amount of voidage in the furnace and a better gas flow. While a negative trend was seen with steam because it lowers the amount of raft, but a certain value of it is necessary because it gives rise to hydrogen in the wash gas volume, which is necessary for the upper permeability. We see that K value decreases and permeability increases with top gas pressure and wash gas volume, as wash gas volume signifies that the reducing gases are present, and top gas pressure ensures that the proper reduction is taking place in the furnace. The parameters did not show a very strict positive or negative relation, suggesting mixed effects. The Python model was made using the 20,000 data samples from TSK, and the 95% of the data went in the training, and 5% of the data was used in the testing of the model. The model accuracy comes out to be of 99.98%, signifying that accurate predictions regarding furnace permeability can be done using this model. The Python model was now transferred into Excel for making temporary calculations regarding total K by feeding in the range of values suggested by the model. The analytical solution was found to be at par with the higher values of CPF, oxygen enrichment, HPT, and draft, with in combination of lower range of steam for effective PCI combustion. The new PCI combustion comes to be of 100 to 150 kg per hour in the comparison of present 70 kg per hour. This better permeability could lead us to better production and fuel efficiency. Moving on to the technological advancements, PCI as coal gas technology can be used in place of the traditional PCI. As in the traditional PCI, unburnt CAR was a problem and coal ash liquefaction problem was seen, and that interferes with lower and middle permeability by participating in slag making and increasing the softening melting zone. In this new technology, the burning of coal powder is shifted to a gasifier and then is introduced in the blast furnace and eliminates the stated problems. The added benefit will be the 50 to 70% of coke replacement with low cost, high ash coal and lower carbon dioxide emissions. Another emerging technology is the auxiliary waste plastic injection. This can be very beneficial because thermoplastics contain a long range of hydrocarbons, which in combination with coal demonstrate a high combustion efficiency of around 80%. That would lead to 15% of coke combustion, lesser coke combustion, and 30% lesser CO2 emissions. This technology can also be a win-win situation for us, as it leads to low presence of sulfur in the steel, as in comparison to coal, plastics have low amount of sulfur. This technology is currently being deployed in Nippon Steel, JFE Steel in Japan, and a few other plants in Austria and Europe. So moving towards the conclusion, the case study was given to the following interpretations: was to keep the parameters in the suggested range and utilize the model for better permeability calculations and predictions. The zonal permeability solutions, as mentioned in the theory, was found to be at par with the analytics. The upper permeability can be improved by acting on the sinter pellet chemistry and burden arrangement. Middle permeability can be kept in control by ensuring a central gas flow and optimizations in the injection position and shape of the injection lances. The lower permeability can be handled very well with lower slag practices with low amounts of FeO in the initial slag. If the technological advancements such as PCI coal gas technology and auxiliary injection of waste plastics is introduced, whilst using the parameter model for permeability calculation, it could boost up our production level and fuel efficiency to newer heights. Thank you.
Thank you for that presentation. Sir, you may continue.
Yeah, thank you, Chaya, that wonderful presentation. So during your study, did you also look at the quality of the raw materials, which you mentioned, the coke, and you also said for sinter lumps as well as pellet? What should
Yes,
be
sir.
the burden? What should be the optimal burden, as well as combining with the coke? And also, when I said it's not only the quantities, it's also the quality. What should be the alumina content and the ash? So have you done that, and is that giving a good advantage in permeability?
It was seen that they were definitely making an impact, but like we cannot control it by much factor. Like after the burden has been charged, so my focus was more on the how to improve the permeability of the furnace whilst looking on the operational perspective.
So the burden you have taken as given, and then based on that, you have done your
Yes, sir.
study for. Okay. So just extending the same thing, you also mentioned about PCI. So
Yes,
does
sir.
PCI, the quality of PCI and all that make any difference in this?
Sir, we are using PCI to cut on the coke consumption because coke is certainly very expensive. The PCI is traditionally made of low coal, indigenous coal basically, and that has more ash content. So that quality certainly matters, but in respect to coke, indigenous coal works very fine.
Because end of the day, you also mentioned low slag rate. So directly the quality of the materials input depends on the slag rate also. That's why I just
Yes, sir.
asked that question. So does high slag rate or high slag generation, would that affect the permeability, or it doesn't have any connect?
Sir, if the slag generation would be more, the layer, the stock line level in the hearth, that would create some problems. Like in the hearth, if the level of the slag and hot metal it rises up by a good amount, that would certainly create troubles in the furnace functioning.
Thank you, Chaya. Over to Purva.
Thank you, Chaya. It was an excellent presentation, and notably, I noticed that you have studied new technologies and incoming best practices and all that. So I had one very small query that while you have suggested certain recommendations, did you benchmark it against other steel companies? Did you get some data around it, or
Yes, sir. So PCI coal gas technology is currently under patenting by certain institutes. So its a real application in the plant data could not be found out, but the auxiliary fuel injection of waste plastic has currently been deployed in many plants of Europe and Japan. So the data of that is currently available, and the mentioned data is at par with their thing.
Thank you. I have nothing more.
Thank you.
Thank you so much, Chaya. If I don't say phenomenal, I don't know what can I say. Fabulous job done. Okay, so next we call upon Kurela Supraja from National Institute of Technology, Raipur.
Yes, ma'am.
Hi, Kurela.
Good morning, ma'am. Hello, ma'am.
Just give me a minute.
Yes, ma'am.
All set for the presentation, Kurela?
Yes, ma'am. Ma'am, can I start?
Just give me a minute. Yes, Corella, you may start.
Good afternoon, everyone. I am Kurella Supreja, a BTech third year Electronics and Communication Engineering student from National Institute of Technology, Raipur. My problem statement of case study is Power Rate Optimization Model for Sinter Plant and Solution Effectiveness. I have prepared this presentation under the mentorship of Mr. Ashish Verma sir. The first question which arises is, what is sinter? Sinter is a small irregular nodule of iron mixed with small amounts of other minerals which can be used in the blast furnace. Sintering technology was originally developed as a means to recycle the iron ore fines and return fines of sinter plant. But now the focus has changed. Sintering now aims at producing high quality sinter which can be used in the blast furnace and increase its efficiency. Sintering process is a thermal process in which a mixture of iron ore, return fines, and other recycled products are agglomerated to form an irregular shaped substance. The basic steps of sintering are mixing of raw materials, passing it through the sinter bed, crushing through a rotating spiker, and cooling in a sinter cooler before being used in the blast furnace. This is the animation which I have made representing the main elements of the sintering process. The power rate of a sinter plant is defined as the number of kilowatt hours required to produce 1 ton of sinter. This is a graph which I have plotted showing the power rate consumption of Tata Steel from 2019 to 2021 June. We can see a significant decrease in the power rate consumption to 2021 June due to the implementation of various techniques like reduction of ideal loads during shutdown and power savings on fans and pumps using digital model. In this presentation, I am going to propose some of the recommendations as shown in the fishbone diagram, which can decrease the power rate further. The first recommendation is based on replacing the incandescent bulbs with LEDs. LEDs prove to be an excellent source of energy as they use 80% of their energy into light, and while the incandescent bulbs only convert 10% of the energy to light. So, LEDs prove to be a great advantage for us. Another added advantage of using LEDs are they are environment friendly and also reduce the carbon dioxide and heat emissions into the atmosphere. So we can save approximately 2,200 rupees per bulb when we have replaced the incandescent bulbs with LEDs. The next recommendation is based on waste heat recovery system. Waste heat recovery system is a method to use the extra heat produced during various sintering processes into useful one. The major portion of waste heat is the sinter cooler. Based on the temperature difference, the sinter cooler can be divided into 5 sectors. And the specific energy levels and energy capacities can be calculated using these formulas. Energy level is equal to 1 minus environmental temperature upon thermodynamic temperature of off gas, and energy capacity is equal to specific heat constant into mass flow rate into thermodynamic temperature difference. On a whole, after these calculations, we can see that the sinter cooler has a potential to generate approximately 145.9 gigajoule per hour of heat, which is simply lost. So this heat can be used in 2 ways. First, in power generation. Second, in producing hot water. This is an animation which I have made depicting the possibility of power generation. The heat from the sinter cooler is taken and is allowed to pass into a HRSG, which converts heat recovery steam generator, which converts this heat into a steam using water as an input. This steam is allowed to flow into a turbine, which runs the shafts of the turbine and changes it into mechanical energy. This mechanical energy can be converted into electrical energy when connected with a generator. The steam in this process can be further made into water using a condenser. This water is again given as an input to the HRSG using the water pump. So this becomes a credit-based system as we are supplying power back again to the power grid from where it is originally taken. And also the steam as well as the heat produced in the process remain unwasted and are utilized. The waste heat recovery system has approximately a payback period of 6.3 years and an economic lifetime of 25 years. The second method is producing hot water. The hot water can be produced using heat pump water heater. The heat pump water heater contains series of tubes arranged in it containing water. When hot air is allowed to pass into it, the water in the tubes gets heated and we can get hot water and cold air as an output. So this hot water can be used in the sinter. It is observed that on increasing the temperature of water by 10 degrees Celsius, the sinter mix temperature increases by 2 degrees Celsius. So this can help in achieving a productivity growth of 3 to 4% and also increases the sinter bed permeability, causing the reduction in power consumption. The next recommendation is based on detection of air leakages. Air leakage are basically leakage of hot air through the exhaust pipes without interfering in the sintering process. Currently at Tata Steel, only air leakages of audible frequency range are detected and treated, while the lower frequency air leakages remain untreated. So, to detect them, a research methodology can be performed in which we can create a support-like structure as shown in this figure with anemometers on top of it. Anemometers are wind velocity and wind pressure measuring devices. When this support is allowed to scan over the sinter bed, we can get the effective flow volume of air through the sinter surface. And using the formula for air leakage, the air leakage percentage can be calculated. This is the video animation which I have made visualizing the whole process. Now, as the air leakages are detected, we can make the process further easier by installing a microphone array beside the pathway close to the traveling pallet. This microphone array detects the lower frequency air leakages. Also, we can plot the air leakage plots in MATLAB using live plotting technique. I have plotted this graph in MATLAB where we can see the air leakages easily. Also, to find the pallet number in which the air leakage is occurring, we can have a radio frequency identification technology, which is thermal resistant type. So this has a unique identification tags which detects the pallet number in which the air leakage is occurring. So this method can help in reducing the air leakage percentage by 5% and also helping easier detection of air leakages, at the same time reducing the wastage of power. The next recommendation is based on auto condenser cleaning system for chillers. Auto condenser cleaning system is an effective method for chillers as it helps in better heat exchange process of chillers. In this method, the first step starts as propelling a barrage of soft balls through the tubes of the chiller, where these are injected through the condenser inlet nozzle. When these balls having slightly higher diameter than the tubes, clean all the dirt present in the inner walls of the tubes and help in better heat exchange process. These balls, when completed the cycle, are captured at the end and are cleaned and also can be used again and again. So this method helps in increasing the efficiency of the chiller by 20% and also reduces the power consumption. This is a video animation where we can see the process more easily. In this way, the dirt in the inner walls of the tubes are cleaned. And also this system has a payback period of only 6 to 7 months, making it a desirable one. The next is incorporating the magnetic tube in the Tata Steel. I would like to demonstrate a physical working model to explain this recommendation. This is a model in which we can see that we have connected a magnet and a SS304 plate in it. When the particles are allowed to flow through it, the particles which are attracted by a magnet, the velocity reduces. These are the iron particles which I have used depicting the charged particles which are attracted by a magnet. So they get arranged in the top layer, while the particles which remain unattracted by a magnet are arranged at the bottom layer. So here we can see that this increases the air filtration velocity of the sinter bed and also increases the permeability, making it reduction in power. On concluding, I can say that the recommendations in this presentation are feasible enough, require less design modifications and installation costs, and can be implemented in Tata Steel. These are some of the references which I have used in making this presentation. At last, I would like to thank Tata Steel for providing me this opportunity, my mentor for guiding me in every step, my parents and sister for their constant support and encouragement. Thank you.
Thank you so much, Supraja.
Thank you, ma'am.
Thank you, Supraja. It's a real good presentation, directly focusing on the power reduction. So, since you mentioned 5 recommendations, so have you attached what percentage, if I implement, I'm not very sure all these 5 would be implemented at the same pace, or we may have some lag in implementing these. So, can you just give the priorities that if you implement this, then it will give you the maximum benefit, so that definitely all 5 would be implemented, but how would you prioritize them?
Yes, sir. So like the condenser cleaning system, that has a payback period of only 6 to 7 months, and also increases the efficiency of chiller by huge amount. Like to 20 to 30% we can increase its efficiency and also reduce its power consumption. Like the chiller in the Tata Steel at present uses 0.5 kilowatt per TR, while on implementing 0.53 kilowatt per TR, but while on implementing this we can reduce it to 0.5 kilowatt per TR. So this increases by huge amount. And also the magnetic chute one, which I have explained at last, that also requires very less design modifications, and also the air filtration velocity through which it is sucked increases from 0.25 meter per second to 0.3 meter per second. So this increases by a huge amount. The waste heat recovery system is very much needed for the present environment, but it requires a lot of time and lot of labor to get implemented.
Thank you.
Thank you, sir.
Hi, Supraja.
Good afternoon, sir.
Good afternoon. A beautiful study on the subject, and I really liked it. Just a small query on the subject is that while you have studied the waste recovery system and its possible opportunities for Tata Steel, did you look at some other technologies, systems, or references of other steel plants, and why is it not being implemented in other places, or is it difficult? So what is your sense of degree of difficulty in whatever recommendations you have suggested to us?
Yes, sir. So like the waste heat recovery system is nowadays being implemented in most of the steel plants. Now they are taking a step forward because it is a requirement for the present environment. Because the heat is simply lost into the atmosphere, the heat is not being utilized, as well as it is damaging the environment also. So the waste heat recovery system, the main disadvantage is like it requires a lot of cost, installation cost. Like it requires approximately 158.30 crores. Putting it in means investing in it for at a specific period of time. That's why maybe. But now in JSW and also in RINL steel plant of Vizag, they are implementing this.
Thank you for your references. Thank you for the response also.
Thank you, sir.
Thank you so much, jury. Simple yet impactful. Thank you for the wonderful presentation, Supraja. Next, we have with us Khushbu Kuntal from IIT ISM Dhanbad. Hi, Khushbu.
Good afternoon, ma'am. Good afternoon, sir.
Good afternoon, Khushbu.
Good afternoon. Good afternoon, everyone. My name is Khushbu. I'm from Mathura.
Khushbu, just give me a minute. Yes, you may start with your presentation now.
I'm Khushbu from Mathura, Uttar Pradesh. I'm pursuing Bachelor of Technology in Mining Engineering from IIT ISM Dhanbad. First of all, I would like to thank you for giving me the great opportunity to work on the project, that is study of diesel consumption, vis-a-vis output, and identify the area of improvement in excavator and RDs under the guidance of Mr. Nimesh Kumar, sir. So the main objective of my project is that I have to study the diesel consumption of HEMM, and I have to suggest measures for the improvement for it. And also I will suggest ways how we can improve our productivity and profitability of our mines. So here is we know that about 50 to 70% of the operational cost is of the haulage, and in which about 40 to 50% is of the diesel. And here is the diesel cost trend, which is increasing day by day. And if I take a rough calculation of the HEMM query AB, about 567 lakh is of query AB we have to spend on the extra cost on the diesel. And here is another need of the study, that some RDs have the less productivity than its fleet average. So we have to increase the productivity of these RDs also. And there are the factors which are considered for the profitability and productivity of any mines. Like there should be the mining plans, equipment systems, operator skills, and operating conditions. And the factors which I have considered in my study of diesel consumption is our idling time, payload loss, haul road conditions, there is lead distance, there is load on canopy, and there are some key performance indicators also. There is time loss in the maintenance hours and effect of excavators. So the most important factor that is responsible for the excess diesel consumption is our idling time, in which our HEMM is available already, but it is not doing anything productive. It is of two types. First one is working idle time, in which our engine is on, but speed of engine is 0. And second one is non-working idle time, in which our engine is also on. Here is the segregation between these two. And from this graph, it is clear that about 3 hours per RD per shift of idling is there because of tea break and operation delay, poor phase conditions, dumper queuing, etc. And here is the delay of the delay in the first and early last roll. And here is the graph showing the breakup of the operative hours of the 100-ton dumper. And here is the calculation due to the operation delay, which cause our idling. It may be due to the delay during the start of shift, which is about 1 hour 5 minutes. It may be due to the earlier end of the shift operation, which is about 41 minutes, and it may be due to the delay in the tea break, which is about 47 minutes. And here is the running time and idle time segregations. So to minimize the idle time, there should be geofence triangulations to capture actual queuing. We can use electric heaters for the morning warm-up time, proper communication, proper maintenance should be there, and we can use rigid AC in the non-working times. Another factor is payload loss. Here is the TPMS data, which is showing there is a TPMS data of 770 fleet, in which it is clear that 16% of the total load is within the range of 80 to 85 ton only. And in case of 70, it is only about 14.8%. And here is the rough calculation of this one. And to maximize the productivity, the shovel operator should be fixed per ship per equipment. And also we can make the incentives based on the payload instead of the number of trips. And third one is our haul road conditions, because RD operator face difficulty if there is a exposed sharp road, narrow entry, and due to the raining. According to a tire advertisement company, if there is a good haul road, then we can increase the production by 30% and we can reduce the fuel consumption by 30%. And there is a time loss if the boulder fall on the middle of the haul road because of the overspeeding, steep ramp, insufficient super elevations, etc. And it takes about 20 to 30 minutes because of the improper communication and low speed of the dozers. And to minimize these times, there should be less steep gradient, there should not overloading, and the height of dump body side should be increased to avoid the boulder spirals. And fourth one is our lead distance. Here is the graph showing the cycle time in case of lead of 1.5 kilometer and 0.2 kilometer, in which it is clear that lead of 1.5 kilometer have more cycle time than lead of 0.2 kilometer. So shorter will be the lead as much as possible, and less will be the diesel consumption and more will be the productivity. There is another factor, that is tire inflation. Because if there is a 1 bar deviation from the nominal inflation pressure, that will cause the significant fuel cost increasement. So tires should be correctly inflated. And if the operator loads the material on the canopy, then extra time required to remove the material from the canopy is 23 minutes 49 seconds. And extra amount of diesel required is 16.4 liter. So load on the canopy should be strictly prohibited. And for that, we can impose the penalty on the excavator operator who loads on the canopy. There are some key performance indicators also. First one is our operator efficiency. RD operator, excavator operator, and water and sprinkler operator all are responsible for the loss in productivity if they have lack of skill, not following rules, attitude, and workload. And it impacts in different ways, like there may be the increasement in the cycle time, skidding of tires may be there, and very low speed. And here are the recommendations, like there should be proper training, they should follow SOP correctly, and they should be confer award and memento, like Sabashi scheme is already there in the Tata Steel, and we can use some softwares to meet the current situation of mine to the operators. Another key performance indicator is our trip loss. Here is the number of trips per RD of each CRD. And if there is 25 RD working at a time, then there will be the 100 trip loss per shift will be there. And here is a Pareto analysis, which is showing that marching and phase preparation are the most contributing factor of the trip loss. So to minimize the trip loss, we should not park all the dumpers in the parking area. We can park some at the phase, some at the dump yard, some in the parking area. Then we can use light pick and drop light vehicles. And last one is our key performance indicator is cycle time of dumper, which is about 15 to 21 minutes. And there are some factors which affect cycle time in different ways, like there may be the mismatch between the excavator and dumper undulations, etc. And to minimize the cycle time, there should be double side spotting, and also efficient fleet management systems should be installed, and proper staggering should be maintained. And here is the speed variations in the loaded conditions at the if there is a haul road in the turning level haul road, upward slope and downward slope, and the speed decreases by more than half in case of upward slope as compared to the level haul road. And in the another data set, one is at the good phase condition, another at the boulder at the phase, and cycle time in case of boulder is more than the good phase condition because of the frequent dozer deployment and difficult handling of the blasted material. And here is the Pareto analysis of the RD maintenance R. And these R's can be reduced by providing mobile maintenance trucks, and also we can implement the predictive maintenance systems using machine learning algorithm, etc. And excavator productivity and RD productivity are interdependent. And to increase the productivity of excavator and RDs, the angle of pass should not be more than 90 degrees. And the recommendations we can use to increase the productivity and decrease the excess diesel consumption are: there should be the predictive maintenance systems, and proper training of the operator should be there. We can use rigid AC in the non-working time. There should be geofence triangulation, and we can use wireless communication systems to provide proper communications. There should be the limit on the overspeeding, and diesel should not fill up to the brim, because it will if it happens, then it will increase our efficiency of the haulage purpose. And also there should be app-based FMS systems, and team-based targets should be there. And we can use drone technology for the strategic dumping and haul road optimization. And in future we can replace our diesel by LNG. And there should be use of the e-dumpers, which are 20% more efficient than our diesel dumpers. And also these e-dumpers are also, we can say that this could be the greenest vehicle on the planet. And these also provides energy in place of more than that they consume the energy. So finally, the conclusion is that to make our mining profitable and to increase the productivity, we have to decrease our operating cost. And also for this, we have to reduce the excess diesel consumption. And by decreasing the non-working idle time, we can increase our productivity. And here are the references. Thank you so much.
Thank you for that informative piece, Khushbu. May I please request the jury to be up on stage for the Q&A round? Yes, sir.
Yeah, thank you, Khushbu, for the wonderful presentation. So you all talked about the skill upgradation of the operators also helps in reducing the diesel consumption. So have you come across any of the initiatives during your study at West Bokaro? I understand you have studied in Quarry AB of West Bokaro. So have you come across any such initiatives?
Yes, sir. Like we can use fleet management systems, which will give us the data that which operator is efficiently working and which operator is not efficiently working. And also this will fleet management systems will give the accurate data, like who is at the time, and who is managing their dumpers or excavator timely, and also attendance management. And everything in the fleet management system, we can schedule the operators, like we can schedule the availability of the operators to the excavator and dumpers. That's it.
Yeah, so fleet management system, as you rightly mentioned, we do come to know where are the wastages and the cycle time increase is happening. But once you find that an operator is not effective, he is not skilled enough to operate, or yes, then how do we address that? Have you come across any such initiative at West Bokaro during your study?
Yes, sir. Then we will provide the proper training to the operators, and for that we can provide the team-based targets. Like there should be like if there is a team of 3 people, then we can keep like 2 people efficient and 1 people less efficient, so that he can learn with them.
So have you heard about the simulator?
No.
So there is a simulator at West Bokaro, so as the other mines also, where you send, once you find that the person's skill level is not up to the mark, you can send him to simulator, and then till that time he doesn't get 0, because every time he does a mistake, it gives him some points. Till that time he doesn't get 0, he can be trained and then again be brought back to the operations. So that is already there in West Bokaro. That's why I was wanting to know whether the practice is there or not. Thank you, Kushbu, and now over to Pravat.
Thank you, thank you, Kushbu, and a very good presentation, and especially when you referred about green or e-dumpers, electric dumpers probably, which are in practice. So this is something which we definitely explore. But just to understand the situation better, did you contact the manufacturers of these equipments to understand what are the best practices to be done in a place where these are used in the given environment, to understand the revision in SOPs so that diesel consumption comes down and there is a cost impact? Did you get in touch with the manufacturers of these vehicles? And was there any recommendations from them which you have incorporated?
So personally, I didn't contact anyone, but I've seen many YouTube videos and of manufacturer like Switzerland company, Switzerland mines are doing this, and I have gone through the YouTube videos. He was explaining that the largest capacity of the e-dumpers is 110, that is 100 ton, that is available in the mines, and it was developed in the 2017, and also it can give the energy in place of the consumption of the energy about 200 kilowatt hour every day. And also we can every country is focusing on we have to reduce the NPV, we have to do the NPV is equals to 0, like net neutrality should be 0, like carbon emissions should be 0. And this e-dumper is creating like emission of carbon dioxide is like negligible, not only negligible, it is 0. And also e-dumpers are 20% more efficient than the diesel dumpers. And e-dumpers are providing, like, we can also get the powers from there instead of the it works on the regenerative braking systems. Like when it comes down from the downhill, then it generates power. And also there should be 93 ton dumpers, 93 e-ton dumpers, 65 e-ton dumpers are also available, and its weight is about 125 ton. And also the cost is very low. The main advantages of this is that the cost of this one is very less.
Thank you. I had one more query. Based on your recommendations, all the 6-7 recommendations, 2 points on that. How many of them did you find was under implementation or not implemented, and how many do you think was being considered? That was number one. And number two, if we implement all of them, what could be the percentage diesel consumption coming down or in the West Bengal area or in the mining setup?
Yes, sir. Like first one is our diesel should not fill up to the brim. Like my father is also a driver of Max Tata pickup, and he tell me that if there is if we fill up the tank, then it will consume. The power available for the hauling will be less if there is we will fill the tank up to there is a demand. And the second one, I can use that predictive maintenance systems for the increasement of the productivity. Like we know that 70% of the, according to a general, 70% of the failures in the dumper maintenance, which includes the hours, 70% of the time is 70% failures are the failures which are unpredictable. Like we don't know how these failures occur. So for that, we can use machine learning. Like we will learn the machine from the previous year data, like this type of failures are there, and it will learn the things, how the failures are occurring and what is the MTF between these failures. Then we can predict the failure time, and we can reduce the MTBF. And there is use of rigid AC. Like it is based on the battery. If the operator if the dumper is not doing anything, then we can start the rigid AC, which is based on the battery. So in this, we can also reduce the diesel consumption. And also already CIL is using LNG pilot project, already pilot project is already there of LNG. But for that, complete setup should be there, like minus 162 degrees Celsius temperature should be there to liquefy the natural gases. And like geofencing, for that, this is the use of the GPS systems. App-based FMS, every operator can have the systems, have the software. So it will be easy, and the limit on the overspeeding, that will depend on the operator efficiency, like how much trained our operator is there.
Yeah, connecting to your last point, the speed limit of 30. So I would like to understand more about this initiative. Is it from safety factor consideration that we are limiting the speed, or how does it impact the diesel consumption? It can be 35 or it can be 25. So how did you recommend 30? Is it some standard safety guideline or something else?
So it includes both, for the safety purpose also, and also it includes the diesel consumption. If there is a more speed, then the wearing of the tires will be there. That will increase our operation cost, because investment will be there in the in the tires. And for that, we can also use good efficient tires also. Good wear tires, I think, is there. And also it is for the safety purpose also. If there is a more speed, then the wearing of tire will be there, and the operator may be injured.
Thank you so much, Khushbu, and really appreciate your responses.
Thank you, jury. That was terrific. You managed to keep all of us virtually engaged to the finest details. All the very best, Khushbu.
Thank you.
Next, we have with us Mridula Venkat Narayanan from National Institute of Technology, Trichy.
Hello, ma'am.
Hello, Mridula. Good afternoon.
Good afternoon, ma'am.
Can you please turn your full screen mode?
Can I start over, ma'am?
Yes, you may start with your presentation.
Good afternoon, everyone. I'm Mridula Venkat Narayanan, a pre-final year student currently pursuing Metallurgical and Materials Engineering at NIT Trichy. Today, I'm going to be talking about the relationship between arcing profile on heating rate and nitrogen pickup in a ladle furnace. So, talking about the importance of my case study, if the HS800 and HS1000 grades of steel produced at Tata Steel Kalinganagar have excess nitrogen content, microalloying with FeNB and FeTi is carried out so as to compensate for the loss in strength. But these microalloying additions result in huge cost for steel manufacturing. It was found that a 10 ppm reduction in one of the HS grades produced at TSK had saved greater than 3 crores, which is a substantial amount. So looking at a typical steel making process occurring at Tata Steel Kalinganagar plant, we noticed that 8 to 20 ppm of nitrogen pickup occur in a ladle furnace where arcing is carried out so as to compensate for the loss in temperature. So the objective of my case study is to study various arcing characteristics that have an impact on heating rate and nitrogen pickup, establish relationship between these quantities in terms of their arcing characteristics, and reason out feasible solutions in order to obtain reduced nitrogen pickup and higher heating rates. So my case study, in addition to adhering to the stringent nitrogen levels required for several critical grades, also has a huge financial impact. So delving deeper, as you can see, a ladle is a marginally tapered vessel in which an arc is struck between the tip of an electrode and a metal bath, generating heat that is transmitted via convection and radiation. Further, arcing gas is injected from the bottom of a ladle furnace so as to ensure the homogeneity of a bath composition and temperature. Now, how does the presence of arc impact the kinetics of nitrogen absorption into steel? As you can see, the reaction of nitrogen absorption into steel is controlled by several elementary steps. Despite that, the rate determining step will be the dissociation of nitrogen molecule on the iron surface in the presence of higher sulfur or oxygen content, which is the case in our problem. Now, dissociation, being dependent upon temperature, will therefore be enhanced by the presence of an arc, and this could lead to greater nitrogen pickup if the melt is left exposed to the atmosphere. Now, moving further, where does nitrogen pickup occur in a ladle furnace? There are two major sites. The first one is our open eye. So, when arcing gas is injected from the bottom of a ladle furnace, the gas bubble rise due to buoyancy, encroach the slag layers sporadically, and this results in the formation of an open eye, which is a potential site for nitrogen pickup. And as the area of this open eye increases, the probability for nitrogen pickup is also found to increase. Now, this area is found to be dependent upon two major factors, that is the gas flow rate and the thickness of a slag. As the gas flow rate increases, the area of your open eye is found to increase in an approximately linear fashion, resulting in higher nitrogen pickup. And as the thickness of a slag increases, the area of an open eye decreases exponentially, resulting in lesser nitrogen pickup. So now moving on to our side 2, that is during arcing, when the current passes through the electrode, it generates magnetic field that creates an axial force on the metal bar, leading to the formation of a depression-like region. While this could be advantageous for submerging an arc, leading to greater thermal efficiency, there are possibilities that this depression could get exposed to the atmosphere, resulting in higher nitrogen pickup. But proven research show that in the presence of a thicker slag, it's highly unlikely that the entire slag layer is blown away during arcing, resulting in lesser nitrogen pickup. So now, investigating the effect of a slag thickness on our heating rate, in a three-phase system that is predominantly used, as the current passes from one phase to another, it generates arc deflecting forces that manifest itself in terms of thermal loads on the furnace wall. But in the presence of a thicker slag, the thermal stresses experienced by the furnace wall decreases, and this could lead to greater thermal efficiency. Also, as I've already mentioned, in the presence of a thicker slag, as the slag thickness increases, the area of our open eye decreases, which means reduced heat loss from these regions, which means higher heating rates. So in conclusion, the thickness of our slag plays a vital role in order to ensure reduced nitrogen pickup and higher heating rates. Now, yet another pivotal factor that plays a huge role in order to achieve our objective is the treatment time in ladle furnace. So arcing can be carried out either a prolonged treatment, a very short treatment, or a relatively short treatment. But since prolonged treatment and a very short treatment results in higher nitrogen pickup, we go forward with a relatively short treatment that requires higher heating rate. So the higher heating rate for relatively short treatment to facilitate reduced nitrogen pickup can be obtained in the presence of a stable arc and a thicker slag. Now, assuming the presence of a thicker slag, we are more concerned about improving the stability of our arcing operations. And for that, we must be mindful of the following parameters. Starting off with the transformer power, the efficiency of heating and melt will be determined by the power supplied by the arc system, and that in turn will be determined by the active power supplied by the transformer. So as the active power supplied by the transformer increases, the arc power increases in a linear fashion, resulting in higher heating rates. Now, this higher arc power can be obtained by either having higher arc voltage, lesser arc current, or higher arc current, lesser arc voltage, as these quantities are inversely related for the stable functioning of our arc, unlike conductors that share a linear relationship between current and voltage. Now, since higher current leads to more electrode consumption, it is not cost effective, and we go forward with carrying out higher arc voltage, lesser arc current. Now, this higher arc voltage will manifest itself in terms of higher power factors in the range of 0.7 to 0.85 and longer arcs. Arc length is defined as the distance between a tip of our electrode and a metal bar, and it is found to be linearly dependent upon our arc voltage. Further, as our arc length increases, the average temperature of our metal bath is also found to increase in a linear fashion. Now, in the presence of a thicker slag, as per our earlier assumption, we go forward with argon purging so as to homogenize our bath temperature, as we have already achieved higher temperatures in our bath due to our long arc function. Now, as the slag thickness increases, the area of our open eye decreases, which means reduced nitrogen pickup and higher heating rates, fulfilling our objectives. Thus, following this sequence of arcing operation by optimizing all the arcing characteristics I mentioned thus far will enable us to achieve our objective. Now, moving further, I propose 5 technical solutions in order to achieve the objectives. My first technical solution is the removal of nitrogen from steel using novel lime-based fluxes. From a literature reading, I also observed that we could use novel lime-based fluxes in the presence of titanium dioxide or barium oxide additions in order to facilitate higher basicity to remove nitrogen from steel. So, according to experiments, using 20 kg of these slag systems for 1000 kg of steel containing 0.05% aluminium is found to decrease our nitrogen content from 100 ppm to 33 ppm, which is a substantial amount. In conclusion, using these novel lime-based fluxes will not only ensure reduced nitrogen pickup and enhance the heating rate by acting as a protective cover for a melt, but it will also remove nitrogen from steel if there is any. My solution number 2 is co-injection of argon-methane gas mixture through our hollow electrode in the presence of a thicker slag. Now, when methane addition ratios ranging from 5 to 20% is injected through our hollow electrode, the minimum heating rate is found to be enhanced by 1.6 times. And the current amplitudes are much more stable in this case, which will be beneficial for submerging our arc, resulting in higher thermal efficiency. Also, using a thicker slag will also enable us to achieve reduced nitrogen pickup. My next technical solution is our foamy slag practice. So, as we all know, the slag system used in a ladle refining furnace is reducing in nature, and for this reason, large quantities of gas cannot be produced. And hence, my technical solution incorporates the addition of foaming reagents like dolomite and coke powder through the hollow electrode into the slag region of our ladle furnace, where it decomposes to form a foamy slag that shields our arc, thereby resulting in lesser nitrogen pickup and higher heating rates. And my last two technical solution predominantly deals with shifting over to a unidirectional current flow so as to reduce the arc deflecting forces in order to enhance the heating rate. And using a thicker slag system will also ensure reduced nitrogen pickup. My fourth technical solution deals with shifting over to a DC furnace with the slag system. And as we all know, a DC furnace uses a unidirectional current flow, which will help us enhancing our heating rate. And my last technical solution is a practice that has been incorporated in the electric arc furnace. And this involves the secondary windings of a transformer forming three independent single arc power systems rather being connected in a triangle through bus bar bridges as it is done in the conventional case. Now, this will result in a unidirectional current flow, enhancing our heating rate. Now, incorporating this in a radial furnace, along with the presence of a thicker slag, will help us achieve our objective. Also, from my literature reading, I observed that there could be a variety of other causes for nitrogen pickup, and I have depicted all the other causes in the form of a cause-effect diagram, as you can see on the slide. Further, I performed data analysis using the data sets of Tata Steel Kalinganagar plant. Nitrogen absorption was estimated for several parameters like an arcing parameter, bath chemistry, and a slag chemistry, and an equation was obtained using the multiple linear regression analysis technique of Python. The equation obtained is as seen on the slide. So this is the novelty I bring to the table from a case study. So what can be done under the prevailing conditions of TST in order to reduce the nitrogen pickup and enhance the heating rate? So from my heat map, I noticed that there's a relatively high positive correlation factor for manganese, chromium, niobium, and titanium. Hence, I suggest post-arcing addition of these elements. Further, as the silicate dioxide content in a slag system increases, the nitrogen pickup is also increases, and this is concurrent with my literature reading as well. Hence, I suggest avoiding silicon dioxide content in a slag. Further, as the titanium dioxide content in a slag system increases, the nitrogen pickup is found to increase, and this is in contradiction to my literature reading. And this could be due to the interaction between several other parameters in a slag system, like silicon dioxide, for instance, which was absent during our experimental condition. This marks the end of my presentation, and I would like to conclude by saying that we could reduce the nitrogen pickup and enhance the heating rate by optimizing all the arcing characteristics I've talked about. And I believe that my industrial solutions can be implemented on a real scale. So I would like to thank my mentor, Mr. Pabitra Pallai sir, his colleague, Mr. Prabir Kumar Sahu sir, also my professors, Dr. Raman Shankar Narayanan and Dr. Muthusamy sir, and all my other faculties, and my family members for their support, without which this would have been impossible. Also, I would like to thank Tata Steel for giving me this wonderful opportunity. Once again, thank you, everyone.
Thank you so much, Mridula. May I please request the jury to come up on stage for the Q&A round?
Yeah, thank you, Mridula. It's definitely a technical presentation, as well as you mentioned also that all these 5 are technical solutions. So have you done any cost attached to it? Because see, when we talk about any solution, we would see how much it is going to be cost effective. And we also say, number one is feasibility, the other one is the implementability, ease of implementability. So if you put all these 5 on this graph, where these initiatives stand?
All right, sir. So starting off with my fourth solution, that is DC furnace, sir. So the installation cost for DC furnace is comparatively higher than that of our AC furnace, but calculations on payback indicate that we could recover this extra cost in a year or 2. So that way it is feasible, sir. And talking about my Hall electrode, so now the price of a graphite electrode, solid electrode, soaring up, sir. And right now, 1 ton of our graphite electrode costs about 2 lakh INR, sir. So shifting over to this Hall electrode can be advantageous because, like, first of all, starting off with the raw material cost, raw material cost will be comparatively lesser for Hall electrode than that of a solid electrode, sir. That is a point number 1. But we should also take the fabrication cost into account. Since Hall electrode will require some novel fabrication techniques, the fabrication cost for Hall electrode will be comparatively higher. But taking into consideration the operating costs, sir, the specific power consumption will be reduced by 3 to 5%. So the operating cost when we are using a Hall electrode will be lesser than that for solid electrode. So I believe this will, for using a Hall electrode, like adding all of these will be better, sir, in terms of cost. And now moving on to our slag, novel slag-based system, sir. So I am not sure about the cost of these novel fluxes, sir, but then I did some research about the feasibility of resources, sir. And titanium dioxide can be obtained like in the Ganjam district of Odisha, which is about 5 hours from Kalinganagar. And Ganjam district produces about 8,284 tons of rutile in the year, produced about 8,284 tons of rutile in 2018. And also Tata Steel has proposed a new project to produce about 1 lakh tons per year of titanium dioxide mined from the beach sands of Thoothukudi and Tirunelveli district. So in terms of availability of resources, I think this will be feasible enough, sir. So I think that answers your question, sir.
Yeah, thank you. Thank you for your wonderful response. Thank you, and over to Prabhat.
Thank you, sir.
Thank you, Mridula, for a detailed presentation. Let me just have few clarifications. So, did you consider Kalinganagar's grade mix production before coming to all these technical solutions, and uh, does it increase the flexibility of Kalinganagar or decrease the flexibility of Kalinganagar if these solutions were implemented?
Yes, sir. So basically, my project predominantly deals with two grades, sir. I consider the HS grade, sir, HS 800 and HS 1000, sir. So most of my solutions actually deals with the mostly deals with the external things, sir, like the construction of our electrode and construction of our like external things like the EAFIC deals with the secondary windings of a transformer. So it does not, we do not directly deal with the chemical composition or slag chemistry as such, sir. So I believe this will be quite versatile since we are just modifying the external parameters like Hall electrode geometry and all of that, sir. And moving on to the novel technique I suggested, that is post-arcing additions. I believe it will be feasible enough because the subsequent technique will be desulfurization, sir, and for that it should be compatible enough. And I believe these additions do not affect desulfurization to a greater extent, sir.
Yeah, and my question comes from there itself because most of them were external in nature. So it cannot be modified heat to heat or grade to grade. So
yes,
it has a permanent impact on the facilities that we have. That is why I was trying to understand that while you are focusing on HS 800 and 1000 kind of grades, but on other grades, what is the potential impact? So that was one subject which I thought would be important for you to consider.
I understand.
The second thing is you have mentioned about the two things, which is graphite is the new gold.
Yes,
and
sir.
Are you only considering the prices or was it something else? Because
that is in terms of the price, sir. Price of graphite electrode.
So, see, tomorrow if prices of graphite electrode comes down because the prices is impacting globally and people are finding solutions and the demand may taper off at a later date, and then so is going out of graphite from a technical point of view right decision?
Sir, like I think using these Hall electrodes will be beneficial because, as I've already mentioned, it enhances the heating rate by 1.6 times. That is the minimum case, and maximum it enhances it by 6.6 times, sir. So it could save up on our operational costs to a considerable extent, sir. So whatever be the case, even if the graphite electrode prices comes down, I think this will be a very good solution for us to explore, sir. Because it's not just about the graphite electrode prices we must be mindful about, but also the prices of the subsequent operations, sir. For example, in this case, if you're using the graphite electrode, graphite electrode, we can improve the heating rates without increasing the arc voltage or increasing our arc length. That means the refractory linings will be safe, sir. It will not be damaged to a greater extent because we are not exactly maximizing our arc length here. But we are improving the heating rate nevertheless. So I feel despite graphite electrodes coming down, the prices coming down, this will be a good solution because it will in turn enhance our operating costs and it will lead to less specific power consumption, sir. So it will also be thermally feasible, thermally efficient, and electrically efficient, sir.
Thank you for your responses. I have nothing more.
Thank you so much, Jury. And I actually have no words to describe the brilliant presentation we just witnessed. Well done, Mridula. Well, we certainly have had a lot of food for thought today, but man cannot live on great ideas alone. So let's disperse for a short tea break. I would request you all to please return to your seats in 15 minutes. Thank you. After a very well-deserved break, it's time to unleash the next set of ideas. May I please have the next finalist on stage, Rishika Singh from IIT ISM Dhanbad.
Hello, ma'am.
Hi, Rishika. You may start your presentation.
Okay, ma'am. Good afternoon, everyone. My name is Rishika Singh. I'm from IIT ISM Dhanbad, and my topic of presentation is establishing CO emission from all the stationary point sources of Tata Steel Jamshedpur. These are the abbreviation terms I'll be using throughout my presentation. Here, TSJ stands for Tata Steel Jamshedpur. As we all know that TSJ has always worked towards sustainable development, but it has never considered CO as its key performance indicator. Yes, obviously, the emission of CO is very less. It's in ppm. But still, I believe that since CO is one of the 6 criteria pollutants and it also causes the formation of other greenhouse gases, CO monitoring must not be ignored. Also, in order to address different economic, social, environmental, and governance issues more effectively, the company must undertake CO monitoring and must also work towards its reduction. There are total 59 stationary point sources in Tata Steel Jamshedpur, which I'll be dealing throughout my presentation. Sinter plant. This agglomeration unit constitutes for more than 50% of the total emission of carbon monoxide from iron and steel plant. Sinter plant in TSJ has total 4 point sources that are the 4 different sinter plants. The CO emission is due to the irregular flow of gases through the fine iron ore particles that are kept on the sinter strand. This will lead to partial combustion and therefore CO emission. The comparative analysis between the TSJ and the reference values shows that the data, the CO emitted, the concentration of CO emitted by the company, this data is not predicted. There might be an error. The data is not precise. There might be an error, and therefore the error must be corrected and more attention must be given to CO measurement. Technique to be considered is emission optimized sintering. The off gas from the later end of the sinter strand must be collected, treated, and recycled back to the strand. This will ensure the waste gas usage and will reduce the CO emission by 50 to 55%. A Poisson process is just like emission optimized sintering process. The only difference is that a particular portion from the later end of the sinter strand is taken care, the off gas from that particular portion is collected, treated, and recycled back to the sinter strand. This will ensure the waste gas usage again and will reduce the CO emission by 30%. Particles must be spread uniformly on the sinter strand. This will reduce the chances of irregular flow of gases and therefore less chance of partial combustion. Pellet plant, this agglomeration unit involves very less CO emission due to the recirculation of emitted gas in the plant. Pellet plant in TSJ has total 2 point sources that are the 2 exhaust fans attached to the induration strand of the pellet plant. The CO emitted in the induration strand is due to the partial combustion of fuel gas. The company does not focus on monitoring CO emission from pellet plant, and yes, the emission is also less, but the reference value suggests that at least the monitoring must not be ignored. Technique to be considered is the recovery of heat from induration strand. The hot air released from the cooling section must be utilized in the burning section for providing heat. This will ensure more waste gas usage and will reduce the CO emission to the atmosphere. Coke oven. This agglomeration unit in TSJ has 7 point sources that are the chimneys connected to the heating chambers present in 3 sets of coke oven batteries. CO is emitted in the heating chamber due to the partial flow of fuel gas. The comparative analysis here shows that the data reported by the company, that is the concentration of CO emitted, this data might not be precise. The error must be corrected and more importance must be given to CO monitoring. Technique to be considered is no disturbance in functioning of oven. The cooking process must not be disturbed in between, otherwise it will lead to imbalance in the coke oven gas used and the irregularity in oxygen circulation. There must be tight closing between chamber and the oven. Any crack or default in both of these will lead to the transfer of coal particles from coke oven to the heating chamber. This will increase the carbon content inside the heating chamber and will also increase more chance of CO emission. Blast furnace. After sinter plant, this iron making unit leads to the maximum CO emission Blast furnace in TSJ has total 13 point sources that are the different hot blast stove and the pulverized coal injection present in 6 blast furnace plants. The CO emission takes place in the hot blast stove due to the partial combustion of fuel gas. Pulverized coal injection that is done to increase the temperature inside the blast furnace might lead to partial combustion of coal and therefore might lead to CO emission. The company does not focus on monitoring CO emission from blast furnace, but you can see the data, the reference data as well as the TSJ data, that the emission is not that less and therefore the monitoring must not be ignored. Technique to be considered is reuse of gas released from blast stove. This will ensure more waste gas usage again and will reduce the CO emission to the atmosphere. Basic oxygen furnace. This steel making unit has total 5 point sources that are present in 3 LD shops. The CO is released from the space between the collection hood and the converter. And since the gap is directly connected to the suction hood, the emitted gas is sucked in the suction hood, treated and recycled back to the plant. This will ensure very less CO emission or very less gas emission to the atmosphere. Company does not focus on calculating CO emission from basic oxygen furnace, and also the emission is very less. Still, the reference value suggests that monitoring must not be ignored at least. Technique to be considered is treatment of iron ore in blast furnace. Iron ore must be treated properly with sufficient amount of limestone in blast furnace. This will ensure presence of less impurities in the molten iron and therefore will lead to more effective use of oxygen for combustion in basic oxygen furnace. Rolling mill. This product making unit has total 12 point sources that are present in total 5 rolling mill. CO emission takes place in the reheating furnace due to the partial combustion of fuel gas. Company does not focus on monitoring CO emission from the rolling mill. And also you can see the reference value. They say that the emission is very less from rolling mill. Still, monitoring at least must not be ignored. Technique to be considered is the recuperation of waste gas and the use of regenerative burner in reheating furnace. Both of these techniques will ensure more waste gas usage and will reduce the CO emission to the atmosphere. Lime plant. This auxiliary unit has total 8 point sources that are the 8 kilns present. The CO emission is due to the partial combustion of fuel gas that's there to convert limestone to lime. TSJ again does not focus on monitoring CO emission from lime plant. And yes, the reference value suggests that the emission from lime plant is less. Still, monitoring at least must not be ignored. Technique to be considered is the limestone must be pre-treated. This will ensure presence of less impurities in the limestone and therefore more effective use of oxygen for combustion in lime plant. Power plant. This auxiliary unit has 8 point sources that are the different boilers present in 3 powerhouses. The CO emission is again due to the partial combustion of fuel gas. The comparative analysis between the TSJ and the reference values shows that if the concentration of CO emitted from the powerhouse is taken around 500 milligram per meter cube at normal temperature, the company will emit an amount of CO expected by the industrial trend. Yes, the emission is less as compared to other plants, but still monitoring must not be ignored. Technique to be considered is recuperation of waste gas. This will ensure again more waste gas usage and will reduce the CO emission to the atmosphere. According to my analysis and according to the data of Tata Steel Jamshedpur, the company might emit around 20 kg of CO per ton of crude steel produced. Here I have considered 11 million ton of crude steel produced per annum. This value is slightly higher than that of NLMK, the company that regularly monitor CO and work towards its reduction. If we consider the concentration of CO reported in the references, then the company will emit a value much higher than that calculated earlier. Technique to be considered for reduction of CO from the whole plant is regular maintenance of everything that's present in the plant must be done. This will reduce the CO emission as the partial combustion will decrease. Computer-aided digital model must be incorporated. This will ensure the sufficient supply of oxygen, and in coking oven will also ensure the perfect coking rate and the perfect coking time. Alternative in TSJ in future when feasible. Electric arc furnace for making steel instead of basic oxygen furnace must be used. This will reduce the emission from blast furnace, coke oven, sinter plant, pellet plant, and also from basic oxygen furnace. Scrap steel recycling business must be undertaken, as this will reduce the emission from all the conventional plants that were involved. Hydrogen must be used for reducing iron instead of coke. This will reduce the emission from coke oven and also from blast furnace. Challenges to the estimation: the concentration of CO in case of TSJ has either been taken from the values reported by the company or by just considering the least count of the measuring device. Both of these data might not be precise. These are the references from where I have collected the data. Thank you. I hope I was able to explain my point.
Thank you so much, Rishika. May I please invite the jury for the Q&A round?
Yeah,
Yes,
so it's good to note that almost 57 points, 59 points have been studied across Tata Steel stationary points. So have you done any reference with TSK, Tata Steel Kalinganagar, because it's a new plant?
No, sir, I have concentrated to Tata Steel Jamshedpur, and I have used the data of different other companies like Steel Authority of India Limited, Durgapur Steel Plant, and other companies, not of Tata Steel Kalinganagar.
So when you compared with these companies, whether it is NLMK or it is SAIL, Durgapur and all, have you seen the processes are one-to-one, whether the sinter plants, pellet plants, coke ovens, we talked about the lime plant and all these BOF furnaces and all that?
Yes, sir, but there were companies that used different, means there were some companies which used only pellet plant, which inculcated only pellet and not sinter. So that was not the one-to-one thing, but I have saw the, as a whole, I have seen the emission, CO emission.
Okay, so whatever the best, I think, suggestion which you have given is whether we can move to alternate source of for BOF also, and also for use of hydrogen in place of coke making and all. So what do you think? Because since you have studied the entire thing, what should be the timelines for going it? Because it is going to be a big change in the investment and all that.
Yes,
and
sir.
apart from the other sessions which you have given at each and every plant, whether it's pellet plant, center plant and all that, how should we monitor and what can we address? Apart from that, you have given these big capex oriented numbers. So what do you see? How do you see the timelines for these?
Sir, in case of hydrogen-based reduction, there is only one company, that's SSAB, which has established a plant. It's a steel company which has established a hybrid plant, but the plant is not under operation right now. They are on the initial stage only. So it will take a long time. It might take 4 to 5 years as well for a company to accept this thing. And for Tata Steel Jamshedpur, it will also take more than 4 to 5 years maybe, because adapting a very new technique and removing all the conventional plants will take a lot of time. And also, sir, for scrap steel recycling business, in India, using scrap steel is not that organized right now. Yes, Tata Steel has commissioned a plant of 0.5 million ton per annum in Rohtak, Haryana, but it's on the initial stage. They are collecting the scrap steels only. So if Tata Steel Jamshedpur wants to establish or wants to look forward towards scrap steel recycling business, it should start collecting scrap steel like from ship graveyards or from any other sources. Then it would be able to inculcate this process.
Thank you. Thank you very much. It's a nice presentation.
Thank you, sir.
Hi, Rishika. Thank you for the presentation. I had one query. You would recall that CO is used as a fuel in the various different furnaces across Tata Steel, and there is a. So, did you study the entire supply chain in terms of where potentially further it can be, while you have gone to different departments and existing mechanisms? Did you get a chance to look at that data?
Yes, sir. So as a whole, like coke oven gas that is released from coke oven, it also includes some percentage of carbon monoxide, and also the BOF gas, that's the basic oxygen furnace gas or the blast furnace gas. These gases are specially used in power plants as fuel. Power plant uses COG gas, BF gas, and BOF gas as fuel gas. And also, like in coke oven, we can use COG gas, that's coke oven gas, in heating chambers, as it will act as fuel gas. So it's not like if we work on collecting these gases that are released, we would be able to use them in the same plant maybe, or in the other plants as well.
Yeah, thank you. I have nothing more.
Thank you so much, Yuri. The competition heat is building up as we keep witnessing such incredible presentations. Fabulous work, Rishika. Next, we have with us Rupali Sahu from College of Engineering and Technology, Bhubaneswar. Hi, Rupali.
Hello, ma'am.
Good afternoon.
Good afternoon, ma'am.
Can you please turn on the full screen mode? Yes. You
Should
may
I-
start with your presentation, Rupali.
Okay. So, very good afternoon to the esteemed jury and my fellow members. I'm Rupali Sahu from a College of Engineering and Technology, and I'm going to present a case study on the root cause of coke fines conveyor 1 and 2 trippage during startup. Sorry, it's... Okay. Introducing about the conveyor belt. So conveyor belt is an endless loop which acts for the quick and efficient transportation of wide variety of materials through large distances. So here I have the schematic representation of the conveyor belt and the working of the conveyor belt. My topic of focus is the coke fines conveyor 1 and 2. These coke fines conveyor carry the coke fines from the center and the surface coke bins in the stock house to the fine bins, and the material size is around less than 60 mm. I have included the belt technical data which carries the specifications of the CFC 1 and 2. Quickly focusing on the problems faced during startup. So during startup, these conveyor belts tends to trip. Because of this trippage, not only do we lose 1 to 2 hours of our operation, but there is a loss of hot metal production as well. Approx production being 375 tons per hour, and the cost of production is 10,000 tons per rupees 10,000 per ton. So there's a huge amount that we lose. So the causes of trippage is identified to be motor overloading. So motor overloading can occur due to two reasons, because the defects on the load side and the defects on the electrical side. The load side defect may include the friction in the idlers, bearing failure, swaying of the belt, and many more. And the electrical side can include overcurrent, overheating, single phasing, and many more. Beside is the statistics of failure mode and induction motor represented through a pie chart. Explaining the mechanical causes for motor overloading, first we have the conventional system of belt skirting. These belt skirting can be over-tightened in some cases, which puts undue pressure on the belt, and that puts load on the motor. Then the friction from the idlers, here steel idlers, because steel idlers are mainly used in the industries. So because of this friction, there is increase in tension, belt wear increases, and thus it demands more power during startup. Failure in the bearings. So bearing failures can include improper lubrication, contamination, fatigue failure, misalignment, and also inadequate internal clearance, which affects the lubrication viscosity. Now, the belt swing. If during startup, if the belt is not centrally aligned, then it can also cause load on the motor. And the gearbox failure, gearbox can fail due to a decrease in the oil level, worn out teeth, and many more, and cause load on the motor. Proposing the solutions to reduce overloading caused by the mechanical causes. So first is the self-adjusting skirting system. On comparison to the conventional belt skirting system, where the common issue is to maintain an effective seal with the conveyor belt, this system provides a dynamic system which automatically compensates for the conveyor belt movement. It has a curved rubber section which maintains proper contact with the conveyor belt. It has got diagonal grooving channels which transports the spillage material back into the conveyor. Then it uses a quick release clamping mechanism for the easy seal replacement. And lastly, it has an automatic pressure control mechanism to maintain the correct blade belt pressure. And thus, this over-tightening issue from the conveyor belt system could be solved. Next solution is for the tension in the belt cleaners. So the recommended solution could be the usage of air tensioner in the belt cleaners. These new power air tensioning systems are equipped with sensors which automatically backs up when the conveyor runs empty, thus reducing the belt wear. It maintains correct belt tension, thus reducing power demand during startup and reducing the labor required to maintain this belt tension. Then we have the improved lubrication system. So for this improved lubrication system, I would recommend the solution to use the automatic lubrication system, which is a very good way of maintaining machine availability. One of the type of automatic lubrication system is the dual line system. It has a widespread, it widely spreads of up to 2000 lubrication points over a distances of 120 meter or more. Each outlet is visually and electrically monitored, and thus there is a 50% savings in the lubrication cost due to proper timing and accurate lubrication doses. Next is the use of efficient rollers. Efficient rollers like HDPE rollers can be used instead of steel rollers because it has a high impact strength, less power consumption during startup than the steel rollers. It has low coefficient of friction than the steel rollers, and hence there is less buildup on the rollers, and it's non-corrosive and also 50% lighter than steel, as we can see from the mentioned table below. Here is a proposed idea for the conventional belt pulley. So instead of the conventional drive system, I would like to recommend the use of motorized pulley. This is a new innovative design where the induction motor and the gearbox is self-contained inside the pulley. So some of the advantages are improved safety because there are no external moving parts. So it is safe for the workers working in there, consumes less power because of its gear design, low noise, it produces low noise, unmatched durability. Research shows that it needs maintenance only after 50,000 hours of operation. And lastly, it is space saving because of its compact design. So performance case study was made in South Africa. This motorized pulley was installed in a coke plant, and conventional drive system was also installed, and both the systems, the electrical readings were taken simultaneously, and it showed that this pulley shows an improvement of 14.3% in the reactive power, thus making it suitable for the industrial use. Next, I would like to focus on the electrical causes. So the induction motor trips because during startup, there is a high momentary surge of current. And this current is known as the inrush current, and its value is more than 10 times the full load current. So why does actually this inrush current appear? So when the supply voltage is given to this induction motor, the high reluctance is produced inside the motor. And also a back EMF, according to Lenz's law, is produced inside the motor. And this back EMF produced is very low because the speed of the motor is low. So because of this low back EMF and the high reluctance in the induction motor, this inrush current is allowed to flow into the circuit. And thus it causes electrical and mechanical damages to the motor in long run. So to overcome these problems, I would like to suggest the solution of using inrush current protections in the circuit. Soft starter is a reduced voltage starter which gradually increases the voltage during startup, and thus it maintains lowers the high starting current and maintains the inrush current. Thermistor, which is the NTC based current limiter, that is the negative temperature coefficient. It is a temperature coupled resistor. So during startup, when the temperature of the circuit is low, it produces a high value resistance, and thus it does not allow the high inrush current to flow into the circuit. So after analyzing the possible causes, the ultimate cause could be the insufficient power supplied by the existing motor. So the recommended solution could be the installation of a motor with higher capacity. So I have taken the design technical specification of Coke Fine's Conveyor 1, calculated the weight of the material and the other details. Then I have calculated the motor power using the effective tension formula, and several factors in the motor power formula is TS, which is the skirt-board friction factor. TX is the tension from the carrying idlers. TYC is the tension when the belt flexures over the carrying idlers. And TYM is when the material flexures over the carrying and the return idlers. TYR is when the belt flexures over the return idlers. And TM is when the tension from the force needed to lift or lower the material in the conveyor belt. So the effective tension calculation came to be 923.82 pounds. Now, from this belt, from this effective tension value, we can calculate the belt HP, which is the tension into the velocity by 33,000, and it came to be 8.26 HP. Adding the 5% speed reduction loss, HP at the motor shaft came out to be 8.67 HP. So the selected motor that should be installed should have a rated power of 10 HP. Previously, the production was low; it was around 50 to 60 HP, and thus the existing motor had a power of 7.5 HP. With the increasing production of around 30%, the motor power should be increased. So gearbox can be designed accordingly, taking the input and the output RPM. And here is the model of the gear motor and the working of the gearbox design in SolidWorks. So I would like to conclude that the solutions that I have presented should be feasible and cost effective. And as we say, time is money. It would save a lot of time during startup. And lastly, I would thank Tata Steel for providing me with such beautiful opportunity, and my mentor, Mr. Sumit Ranjan, for his timely help. Here are my references. Thank you and have a great day ahead.
Thank you so much for the presentation, Rupali. May I please request the jury to come up on stage for the Q&A round? Yes, sir.
Thank you, Rupali. It's a very good presentation, and you identified the basic reasons and how do we address these. So, have you attached any cost to this? Because when we say that we need to implement these preventive measures, so how does cost look like? Number one, and a comparison between the benefit which you are going to get vis-a-vis the cost we are going to spend, and the timelines which are there for addressing these issues.
Okay, sir, considering the cost, exact cost, I haven't noted down the exact cost for this motor replacement and all. But since the cost of because of this strippage, since the loss of cost is around 40 lakhs and nearly 40 lakhs, because 1 to 2 hours of startup delay is a huge thing. So if we replace this motor like it would save the time, and thus it would compensate for the losses that we incur. So exactly because it is a permanent solution. So if we implement it now, then we can save the cost that we lose in future. So exactly the cost I haven't calculated, but I have just given the solutions to it.
Yeah. So second is, have you done any feasibility analysis of these that maybe the priority wise these 2-3 we can immediately implement and we can get benefits? We generally call low hanging fruits. So which one do you consider? Which one or two which are low hanging fruits which can be immediately implemented, and the rest of the things like the motor and all will take some time to procure and all that?
Yes, sir. So, sir, if we consider the immediate implementation of the solutions, then the usage of one second. Okay, so the usage of the mechanical solutions that I have implemented, like the rollers and the lubrication system. So lubrication, these are very small problems that occur. So if we use a very efficient system to overcome this, then we can immediate implementation can be this, and the motor replacement can be a great implementation, because it would really solve the problem of the stripping issue.
Thank you very much, Rupali. Now over to Prabhat.
Okay.
Yeah, thank you, Rupali, for the detailed presentation that you have made. During your study, apart from the references, did you look at other benchmark plants, and who were your, apart from Sumit Ranjan, did you consult the experts within Tata Steel or outside Tata Steel to figure out whether your solutions are the best or there's something more efficient being practiced somewhere else?
Okay. Yes, sir. So apart from inside Tata Steel, my mentor was only the guide. And apart from Tata Steel, since I'm from Rourkela, RSP, I had contacted some seniors in RSP, and this stripping issue is mainly, I think this stripping issue is mainly in Tata Steel Jamshedpur, because in RSP, when I had talked to the experts, they said that the conveyor belt doesn't trip very often. And when I asked solutions to them, so they said that maybe the rollers may be inefficient, or there may be more tension during startup. And lastly, they suggested that if all these mechanical equipments are working fine, then the ultimate solution would be the replacement of the motor. So I haven't visited to the plant because it it was very restricted. So yeah, they had suggested me this.
Thank you. It was good. So another query I have is that did you look at someone who is supplying these conveyor belts to the various plants as supplier, and maybe understood from them what would an integrated conveyor belt equipment look like, which will have a proper motor, which will have a proper roller, idler. So did you get some inputs from manufacturers?
No, sir. As of now, I haven't contacted any manufacturers for this.
No problem. So thank you so much. It was wonderful.
Okay, sir. Thank you so much.
Thank you so much, Yuri. And now that's what we call throwing the ball out of the park. Great presentation by Rupal. So while we had a lot of new information setting in our systems, it's time we grab a bite. Let's move on to a short lunch break for 30 minutes.
Thank you.
Welcome back to Tata Steel Women of Metal Challenge. So while we are back from the lunch, it's time that we move on to the next presentation. Next, we have with us Soumya Jain from IIT ISM Dhanbad.
Hello, ma'am.
Hi, Soumya. Good afternoon.
Good afternoon. Good afternoon, sir. Good afternoon.
You may begin with your presentation, Soumya.
Thank you, ma'am. So, a very good afternoon to all present here. This is Soumya Jain from IIT ISM Dhanbad, and the topic given to me was optimization of reagent dosing in froth flotation cell of Payload coal processing plant to maximize the froth flotation yield. I got the opportunity to do this project under the guidance of my mentor, Mr. Mahesh Kumar. So talking about froth flotation, which is a physiochemical separation process, which works on the principle of surface wettability of the minerals and gangue particles. Coal particles, which are hydrophobic in nature, attach themselves to the air bubble and rise to the surface, which is then recovered from the froth-laden bed. Whereas the impurities, which are hydrophilic in nature, remain suspended and are discharged as dilute slurry waste. Now, the process involves the aeration of these minerals in the presence of the flotation reagents, which facilitate the attachment of these air bubbles and the levitation of those important minerals. So the most important flotation reagents which we will be talking about are collectors, frothers, and modifiers. A collector is a chemical substance that selectively binds to the surface of target minerals and imparts the hydrophobicity to those mineral particles which are necessary for air bubble attachment. It is essential to create air bubbles which form momentarily stable froth. So for this, we add the reagents called frothers. Coming next to modifiers, which are also known as regulators. The main purpose of them is to modify the action of the collector on mineral surfaces and as a consequence, govern the selectivity of the flotation process. Now talking about the factors affecting the flotation process. The particle size. The results show that at lower air rates, the intermediate particle size distribution yields the most stable froth, while at higher rates, the finest particle results in air recoveries. So you can see that it has a crucial important role because smaller the particle, less reagents will be required and more surface area will be exposed and greater will be the recovery. Coming next to pulp concentration and pH. Pulp concentration had the significant influence on coal flotation. Low concentration results in the decrease in processing capacity of the flotation equipment, increase in reagent dosage, and in electricity consumption increase. Also, there is a suitable pH which decides which flotation reagent to be used, and we can have a maximum good efficiency. So, coming next to the reagent system and flotation time. The flotation reagent system involves the reagent types, quantities, and place and ways of dosing, like which reagent should be used so that it does not react with the surroundings and so. And flotation time refers to the time required for separation of minerals when a certain recovery rate and concentrate grade are reached. Coming next to agitation and aeration. Smaller the bubble, the better the dispersion, and large will be the surface area exposed, which is conducive for froth flotation process. Coming next to water quality and slurry temperature. The water used should not contain any suspended particles or any microorganisms which may react with the constituent particles and hinder our process. Also, each process has a specific temperature which shows the maximum yield and gives the best results. Now, let's talk about the Bhelan coal processing plant. It has been awarded as the best operating coal washery by the Coal Preparation Society of India. Here I've mentioned some the reagents which are we presently using in the plant and named according to the NALCO product nomenclature. As you can see, frother N9840, collector, modifier, and Colex. Colex has faster kinematics, and we are recently using it because it has an adherence to even partially hydrophobic substance particles, and it increases yield, improves the quality at reduced low waste. This is the flow sheet of the Bhelan coal processing plant, and after analyzing the data for previous 3 to 4 months, we studied that the average dosage of the following used in the plant are the frothers at the rate of 30 ml per minute, collector at the rate of 600 ml per minute, and modifiers at the rate of 20 ml per minute. Recent research was also carried out where they, studied the various concentrations and of the collectors, frothers to see what effect it has on yield, and it was observed that the dominance of the collector dosage was more, than the frother, followed by the pulp density. Now coming to the recommendations for optimizing the reagent dosage. But most importantly, what should be kept in mind that it should be an economical method, should be easy to implement, should give better results, and most importantly, should be safe and maximize yield. So talking about emulsification. The main difference between normal and emulsified systems are that the pre-emulsification has improved the efficiency of the process. The most prominent feature is the dramatic fall in ash content in the concentrate of all collector system without any exception. It enhances the particle collector emulsification and physiosorption of the cold surface. Emulsification has also increased the flotation rate. That is, the total period to float this coal was reduced by 50%, allowing an increase in the capacity of the flotation machine. The emulsified oils are mobile, and the reagent dispersion is optimum and energy savings is possible. They also lead to the reduce in reagent consumption by a half and improve the performance of the process. As you can see that they carried out in the lab, and they have plotted it also that the recovery was great with emulsification. Coming next was the release analysis, where just they carried and practiced different combinations of the different collectors and their corresponding impact on the yield. It was just a lab activity which they plotted, and they saw that the best results were shown by diesel oil and synthetic frothers. So yeah, we can, if given the opportunity, we can try these combinations to see the impact in the yield in the plant. Coming next to double reagent addition. The feed which is entered in the flotation cell contains 15 to 20% of oversized particles. And these oversized particles, which are of high carbonaceous value, are not efficiently recovered through the flotation process. Hence, our major challenge is to improve the flotation kinetics, especially of these oversized particles. And the way these flotation reagents are distributed, they can impact and cause a great impact. As we suggest for this, the double reagent addition process, and the results of the lab activity have even showed that the improvement in the yield of clean coal was about 10 to 12% with a marginal increase in the clean coal ash content. So yeah, these were the chemical reagent suggestive methods. Now coming next was the intelligent setting method of reagent dosage based on time series froth image. It is well known that the change of reagent dosage during the flotation process will cause the froth image to change continuously with time. Therefore, an intelligent setting method based on the time series of froth image is proposed. Since the reagent will affect the froth image over a period of time, the time series of bubble size cumulative distribution function is processed by the embedded model, and the dynamic feature vectors are output. Finally, XGBoost, which is an integrated learning method, is used to establish the nonlinear relationship between the reagent dosage and dynamic feature vectors. And you can monitor that if the froth concentration is less, then we can check a reagent system if the froth dies out, or if there is a turbulent froth, then we need to check our air checkup system. So yeah, this way we can monitor these and have a great benefit. Not only this, the industrial experiments have also proved the effectiveness of the proposed method, and this method does not require manual participation, avoids inconsistent product quality due to manual experience, and improves the economic benefits. Next is the particle bubble enhancement flotation. The main obstacle of the small particle is that the low probability of the collision with the bubble, and the main obstacle with coarser particles is their high probability of detachment. So for this, we have come with the solution of producing pico bubbles, which are generated by hydrodynamic cavitation. They enhance the coarse flotation process with high efficiency and lower product ash rate. And as a result, since the pico bubbles have an adherence to these hydrophobic particles, they bridge these fine particles to form agglomerates, and thus it has a recovery of fine coal increasing, and consequently, they reduces our reagent consumptions. You can also see that there's a active application in industry, and yeah, how they just act as a secondary collector. These are some minor details which are important, but as they can be taken care and have a great impact. As design of the feed valve when we are pouring so that it is not wasted, and the aeration where we can use spargers to ensure proper dispersion of the bubbles. The blended frothers where the use of a strong with the weak can give a great impact and reduce the consumption to a great extent. And the most important is the proper way of dosing, where we, dose at proper regular intervals and not just at one place, but evenly distributed. So yeah, this was all from my side. Reagent usage and type of reagent have an important role. And our main objective is to just ensure cost reduction while maintaining the quality of the flotation products. Also, I thank you, Tata Steel, for giving me this opportunity to practice and to learn on this case study. It was a great learning experience and I'm highly obliged. Thank you.
Thank you so much, Soumya. May I please request the jury to come up on stage for the Q&A round?
Thank you, Soumya, for the wonderful presentation. So, for optimization of reagent dosing, have you benchmarked with some of the washeries which we do have in the same, you can say Tata Steel, whether they are the JCPP Jharia coal washing plant, or there are two washeries in West Bokaro? And have you made any comparison, and how does BCPP stands compared to them?
Comparison, so there's in Bhilwara, there's Vedanta plant and all. So, but so there, I could not get the data of the other plants. So there, I could not, get a comparative comparison. But to coming to these reagents, the methods which I have proposed, they've been taken from, literature articles and from even some plants which are in practice apart from Tata Steel. So because of the inefficient, I could not have the exact data to continue with my comparative analysis. But yeah, the methods which I have studied, they have been tested and they have a future, and if taken initiative, they can be implemented and, give better results.
Yeah, since these are easy to implement, have you seen any start of implementation of this in BCPP?
Sir, talking about the way emulsification, these are just lab experiments. This has not been yet implemented, but I got it, my mentor, he said that emulsification was tried but could not be, they could not implement it. But if they're looking forward to it, but he basically said that it's an industrial project. So we cannot, afford to perform experiments again and again, because we have to take care of the costing and all. So it's not yet implemented, but the facts that I have, suggested, I have just taken care of things that they can be easily implemented, and they are feasible, from my end, and I have gone through the literature and research papers, and yeah, there is the feasibility of these methods which I proposed.
Thank you, Soumya. All the best.
Thank you, sir.
Hi, Soumya. Thank you. Thank you for your in-depth study of this process. I had one small query. During your analysis of this project, did you only restrict yourself to literature study, or you had some other places to go and look at these processes and suggest measures? That was one query. The second was on when you talked about image of froth and some suggestions around it. So is it something to do with image analytics, which at the back end would be on artificial intelligence suggesting modification of the process?
Yes, sir. So coming to the first point, due to the COVID, I could not have the opportunity to visit the plant to see this in actual. But my mentor provided me with the data for previous 4 to 5 months. So I could have a data analysis, and then I just saw some YouTube videos the working. So I could not have a lively interaction or an experience. So the only thing ready for my disposal was the data and the research papers, and I tried my best to gain as much as I could. And so secondly, coming to the question regarding my image one, yes, sir, it's that only, sir. I'll just give you a brief insight, what I am planning is that, sir, when the we'll be placing a camera, and there will be some sensors which obviously includes AI, and those camera will capture the images, and by analyzing image implementation and segmentation, so those image will be captured and yeah, used by AI and those sensors detection and the reading. Yeah, there's an application of AI. And so as you see that digitalization is getting in every field, so why not here? So yeah, it was an initiative to introduce this, and I hope it will be beneficial because as I stated that it reduces manual participation and improves the economic benefits. And yes, sir, everyone is moving towards digitalization, so why not here?
Thank you. Thank you for your detailed explanation. All the best.
Thank you, sir.
Thank you so much, Yuri, and thank you, Soumya, for that presentation. I must say, each presentation is setting the bar high. Great job done. All the very best for the results.
Thank you, ma'am.
Next, we have with us Tanishta Bagh from IIESD Shirpur. Hi, Tanishta. Tanishta, can you hear me? Tanishta, am I audible?
Yes, ma'am. Yes, ma'am.
Hi, Tanishta. Good afternoon.
Good afternoon, ma'am.
All set for the presentation, Tanishta?
Yes, ma'am.
Okay. You may start with your presentation now.
Warm greetings, everyone. The topic for my case study is reliability enhancement of air slides. In Tata Steel, steel operations are fully integrated, starting from mining of ores to marketing finished products. Thus, procuring good quality raw materials, primarily pure iron, efficiently is a priority. The ore isn't fed into the blast furnace directly, but in the form of sinters or pellets. Use of uniform-sized pellets leads to high metallization rates at lower fuel consumption. Pellet plant of capacity 6 MTPA was established in 2011, expanded to 7 MTPA by 2018 to make pellets for aiding production. The whole process occurs in different sections of the plant. Our focus further would be on the drying and grinding section. Similar to the workflow I followed, the presentation will go ahead with understanding the process in the D&G section about the need, parts, and working of the ear slides in there, validating the components, analyzing delay sheets, finding the problems, their causes, and suitable recommendations to increase its reliability. In the drying section, the moisture content in the ore is brought down to less than 1% by passing hot gases through it while it moves through the air dryers. In grinding section, dried iron ore is ground to the desired fineness. The rock separator classifies ground product into coarse and fine. The coarse material returns back to the mill for further grinding. The fine products are collected in baghouse and conveyed to product silo by air slides and bucket conveyors. About 21,000 tons per day of fines of size less than 45 micron cannot be conveyed by the traditional methods of conveying due to excessive fugitive dust emission. Chutes cannot be given at all places in lack of proper inclination. Iron fines emission should be restricted as they are extremely harmful for our environment. Air slide as an equipment can cater to all the above points, being an eco-friendly option. Energy and maintenance required are low while giving more flexibility to plant design and better use of space. Air slide conveyor is a dust-tight chamber with no moving parts. It is divided longitudinally into an air chamber and material chamber by a suitable porous membrane topped by a perforated steel sheet on which the material is conveyed. Low-pressure air is fed by a centrifugal fan, which diffuses through the membrane, nullifies the interparticle and particle wall contact forces. The particles start to float in the air and behave like liquid. Thus, even the slightest slope of the conveyor causes tons of material to get transported to long distances by flowing under the effect of gravity. Validation of the component in the air slide. The flowability of the particles inside the air slide for its proper functioning depends on many factors. Particle size, shape, density, amount of air input, the porosity of the membrane, etc. Here we have the general assembly design of the centrifugal fan in use and information to carry out the theoretical check. Checking the pressure rating, the total pressure drop is the sum of the pressure drop across the material bed, porous membrane, and near the inlet and outlet. The total pressure drop was calculated to be 768.29 mmWc, and the fan is designed for 771 mmWc. Thus, we are good to go. Air volume capacity check. Size of the air slide taken 15.5 meter in length, 1.2 meter in width. As per the Kauniki model of air slide and taking an FOS of 1.25, the required volume capacity for the fan should be 2715 meter cube per hour, but our fan is 2740 meter cube per hour, thus it's good to go. The casing is designed to handle 3500 mmWc pressure. Polyester air slide fabric can handle temperatures up to 120 degrees Celsius. The air pipes can handle 1 to 2 bars of air pressure. Thus, all the components in use are good for the working conditions in there. Since air slides are material handling and conveying technology, the ultimate effect of the problems occurring in it would cause restriction in the material movement, which we call air slide jamming. And after all the above study, we were able to figure out a number of factors which might cause this jamming. All the possible causes have been categorized under material, method, manpower, and machine problems and put down here as a fishbone cause and effect diagram. A few of them would be poor quality material from mines, wrong operational procedures, fabric puncture, and more. To understand the major problems, we did a Pareto analysis. From the delay sheets of the last 5 years, the frequency of the problem has been represented here as a histogram. Out of all the issues, the 4 major problems were found from 80-20 rule: air slide fabric punctured with good thickness in fabric, air leakage from air slide because of fitment issue, moisture ingress in the material, jammed pipe network, or insufficient air. By the means of a YY analysis, the root causes for the identified major problems were found. 20% of the nibs were smaller than the whole size of the perforated sheet. Fitment correctness cannot be checked at site, and space constraints, lack of moisture removal procedure for moist air, jammed pipe networks caused by missed air pipe flushing schedule, or improper cleaning. Jamming of air slides can be detected by sudden tripping of nearby machinery, dust release from inspection doors and chamber joints, difference in the inlet and outlet material flow rates. Now that we know the root causes, we could figure out the solutions. Taking the mill discharge air slide as an example, jamming of the mill discharge air slide. This is caused due to nibs of smaller size than the holes of the perforated sheet getting stuck in between. The fabric is not very capable of sustaining the frequent scratches and wearing by nibs and thus gets torn, leading to material entering the air chamber and air pipelines. Solution: using perforated sheets of holes having diameter 5 mm instead of 10 mm to avoid slipping of nibs through these holes, thus leading to more durability of the fabric while not causing much hindrance to the airflow. Nib trap air slides are the smallest in pellet plant, which has just 2 chambers. This air slide requires maintenance nearly every 6 months. As we can observe here, the first chamber has a sharp inclination. Thus, we can get a permanent solution to this by replacing the air slide with a chute conveyor. Since we can achieve up to an inclination of 65 degrees, which is greater than the angle of repose for the material, which is 35 degrees, chutes are simple rectangular dust-tight chambers, extremely low maintenance, would not need air to be blown, and do not have any tarnishable fabric within. Product air slides. Jamming in this air slides might cause due to discharge of more material into it, might be due to poor handling of RAV or machine flaws. I read about different fans and blowers which are used to provide air to circuits, and I would suggest the use of twin lobe blower, a positive displacement blower, which will maintain constant air velocity in the pipe against various discharge pressures, thus help prevent blockages, unlike centrifugal fan which are designed to work under a constant pressure difference. The silo top air slides are placed outdoors. Lumping of material inside the air slide during the rainy season can be witnessed here. From climate statistics, we see Jamshedpur experiences a significantly high amount of rainfall in the months of June to September and has a pretty humid climate for half of the year. Moisture-filled air enters the air slides during these months to cause lumping of the material. solution, we can install space heaters to the main pipeline to remove moisture from the air. A temperature of 70 to 80 degrees should be sufficient to remove the moisture, and this temperature is very well handleable by the fabric inside the air slide. The next issue is air and metal dust leakage due to improper fitment of upper and lower chamber. This is because we cannot check if both the chambers have fit well due to the presence of air slide collars. The other issue is time-taking and difficult procedure for changing of air slide fabrics. This is because the pipes beneath need to be cut and welded every time we change the air slide fabric. For this, I have made a CAD model to demonstrate my solution. I suggest the use of a steel bellow, which is a compressible pipe which can be compressed, and thus we can easily easily remove the lower chamber and change the air slide fabric. Also, I have suggested the removal of the air slide collars so that while we bolt both the upper and lower chamber, we are able to check if they have fitted well or not. Finally, I would like to summarize all my recommendations, which are use a perforated sheet having holes of 5 mm diameter, check for imperfections before installing. This can be done by a simple soapy water method. Remove collars in air slide material chamber attaching area, use of bellow, using space heater for air pipes, using chutes instead of air slide wherever the inclination required can be achieved and the distance is less, do regular checks and cleaning. Finally, I would like to thank my mentor, Mr. Apur, manager of pellet plant, and Mr. Vikas Singh, senior associate, for guiding me through.
Thank you for that presentation, Tanishtha. May I please request the jury to come up on stage for the Q&A round?
Thank you, Tanishtha, for a wonderful presentation. So you have mentioned 4 to 5 solutions, in fact 6 solutions for how can we avoid jamming of air slides. So have you discussed with your mentor the feasibility of these? How can we do it? And second thing is, whenever we change a process, we generally look at what is the risk associated and what is the potential hazard that is there within the change of the same thing. So has any discussion happened with your mentor? How do we mitigate the risk also? Because today we could be seeing only jamming, but once you change, you may end up with some other issue, which today I'm not very sure whether we had seen that or not through and through. So did you have any discussion?
Yes, all the solutions, I had a thorough discussion with my mentor. I have tried to keep my solutions very minimalistic. Like while we are going for a change to increase the reliability, we need to make sure that they are not exorbitantly high. The solutions which I have suggested are very simple ones. Like while we are changing the air slides, we need to ultimately remove the perforated sheet too while we are changing it. So when we already have the procedure where while changing the air slide fabric, we have to remove the perforated sheet and then get it back again, we can just simply get the new one and fit it back, so that we make sure that so that can be even checked that if all the fitments are correct or not, so that there won't be any safety issues over there. Even in case of while attaching the bellows, we have already seen the use of bellows in many pipeline areas. They are already being in use, and when we are going to change the air slide fabric, we are ultimately having to cut the welded pipe beneath. And I think that the cutting and welding process in that amount of constricted area, and also welding, is quite risky during the rainy season time. The use of bellow would ultimately be a more safer solution instead of going for the cutting and welding process, which is currently being in use. Apart of that, I think about the implementation of chutes. Chutes do not even require any energy or any other source of energy. And also, when I talked about the nip trap air slide, I got to know that the first chamber has already been replaced by a chute, and the second chamber is a air slide. So why not go for a complete chute over there?
Thank you. And can some of these ideas be patented? Or these are already used in some of the plants and we are trying to implement here?
So most of the ideas which I suggested are quite basic and they are already in use. Like when I talked about the heater, I guess this is already, I got to know about my mentor later after I suggested him that this can be an option. He said that this is already being used in Tata Steel Jamshedpur itself near the bag filters. So I guess all the ideas which I just presented are in use already somewhere and quite tested. And I'm sure that if we implement them, they won't cause any safety risk and would work perfectly fine.
Thank you. Thank you very much. All the best.
Thank you, Tanisha, for getting deep into the subject and looking at it. And I was quite happy to see that you're using some TQM tools like fishbone diagram, histogram, and YY analysis. But my query on the subject is that did you get to do some detailed data analysis? Did you get data, or in absence of data, how did you use your analytics to using the TQM tools to arrive at those solutions? So was data an important part of your analysis?
Yes, sir. So I was provided with the delay sheet of last 5 years. I quoted down all the problems that came up in there. Like in the delay sheets, there was the delay time and also the problem because of which the delay caused, that was also quoted. So I did make an analysis, like make a histogram out of the same, that which problem is occurring how many times. I was like quite amused to see that because air slides are quite simple in nature as compared to the other machineries in use, the frequency wasn't a lot, but since we are supposed to make it reliable and there is a chance to make it even better and problem free, so I did go through all the details in that delay sheet and did the data analysis with the same, which is represented here in the fishbone diagram, the Pareto analysis and the YY analysis too.
Okay. So thank you. One more small query. See, this is not a unique and isolated system as you referred to, that there are many places where Tata Steel itself is doing a lot of modifications. So how many of your suggestions which you have given for this particular project do you think is already in Tata Steel and could just be replicated? And what are, is there some new solution which you have given?
About that, I would like about the new solutions. One of them would be the changing the perforated sheet with hole diameter with a lesser hole diameter. The other one would be like changing it into chute, the nip trap ear slides into chute. Rest, I think the one which is the twin blower, which that is already in use near the reject ear slides. And about the space heaters, though, like originally when I was reading on the internet about how to solve this problem, I got to know about the space heaters, but when I discussed with my mentor, I got to know that it is being used near the bag house and not in any of the ear slides. So that would be, and also the use of bellow, that would be a new one which is not being implemented yet in Tata Steel.
The third query, which I have asked many of the participants, is that these are systems, right? Like end-to-end systems. Did you get in touch with any manufacturer to understand how do this look at this problem and what can be potential solution if they were given the problem?
Yes, sir. I tried to contact manufacturers, not manufacturers, but a local plant, cement plant, which is using this air slides. But since they are dealing with a completely different material, which is cement, their problems is very different. The problem they face is mostly that there is a overload of material, not the ones like nibs one. The nibs here is because when we are grinding the iron ore, there are also hard rocks and stuff, which isn't quite the case over with them. So many of the problems were not faced by them because they deal with a separate material. So I couldn't get much input from their side. I relied mostly on the information from my mentor and from the senior associate of DNG section. He gave me quite a lot of info about how things are there in the plant.
Thank you. It was wonderful, and thank you for your responses.
Thank you, sir.
Thank you, jury members, and thank you, Tanisha, This was the last presentation, and could we have asked for better? Well done. Good luck to you. So on that note, we come to the end of the presentations for this year's Tata Steel Women of Metal Grand Finale. What an interesting and informative day it has been. I think a very special round of applause must go out to our jury members who have been so encouraging, engaging, and involved. Gentlemen, I believe that you have some serious deliberation to do, so we'll let you focus on that. While the judges are put to the heavy task of evaluating all presentations, we have with us winners of previous years. Let's hear from them how their journey has been as a Tata Women of Metal. With great pride, may I please invite Himani Patel, winner of Tata Women of Metal Season 3 from NITK Surathkal.
Good afternoon, ma'am. Am I audible?
Yes, Himani, you are very well audible. Very good afternoon.
Good afternoon to all of you, all the top 10 finalists and all the jury members, to you, ma'am. So I would like to share some of my experience, what it has been like. And I would say that it would have been great if it was done offline, because we had the opportunity to experience all this in offline mode, and it was too good. So I would like to share the selection of like my selection in top 10, how I got it done. So the selection in the top 10 from top 50 was the most nerve-wracking, crucial, and challenging part of the journey. Being in college, I was in college that time. So connecting with the mentor online, studying research papers late into the night, Googling new terms, and then learning from YouTube videos for the project. That was a phase I still cherish and take motivation from. Quite unlike when what you all have been going through last few months, thanks to the online mode of operations now. And ultimately, after 1.5 months of the study time, I presented my solution at an event at XLRI. Having liked my approach to the problem statement and the solutions I proposed, so I made it to the top 10. So after that, the grand finale was another ball game altogether. The venue was Alcor Hotel in Jamshedpur. So the ambience created by Tata Steel at that place was quite good, and there was nervousness. Everything was a unique experience for me. So and I hold it very close to my heart, all that experience till date. And the jury was quite impressed with all the novel ideas presented by the 10 members. We all 10 of us were more or less equal and in our presentations. So there was nothing like being very special to be the winner, but there has to be a winner in every competition. So I was honored and humbled when my name was taken, and I feel this is a very big responsibility on my shoulders, uh, like to win and to keep the spirits high for learning and competing. I'm truly proud of this win and feel that this will help me put in more effort to do very best as I move forward in my career. So I would wish all the participants a very best of luck for your career ahead, and you will get a very nice opportunities in Tata Steel if you join later. So thank you, ma'am. That was it.
Thank you so much, Himani. You are an inspiration to everyone. Thank you for gracing us with your presence.
Yeah, thank you.
Let's add to the already star-studded show and call upon yet another star. Next, we have with us Tanya Maurya, the first runner-up of Tata Women of Metal Season 3 from BIT Misra. Hi, Tanya. Tanya, I believe you are on mute.
Hello?
Yes.
Yeah. So, hello everyone. I hope you all are doing really good. And I'm here to share my experience. So, Women of Metal was a life-changing journey for me. I still remember the summer of my third year when I had filled in the applications for WORM without much thought. The quiz for the initial shortlisting went well, and it was only then that I realized that it was something serious that I was going to be a part of. And then the next step, the problem statement, which I'm sure all of you must have been, putting your heads into for the past few 1.5 months. And for me too, the 1.5 months was like I was the entire day I was just thinking about the problem statement. uh, I had interest in technical problem solving, and that is why I had joined mechanical engineering. But the real world problems were so different than the things that we had read in books throughout our lives. And the fact that the problem statement was so original and so practical, that my interest was spiked even further. I took it as a challenge, and not thinking about the final outcome of the event or of winning, I just put in my day in and out. And there were lots of time of studying, researching, connecting with professors, mentors. And when I finally presented my solution, the best moment was that the judges praised me for the practicality and details shown in the proposal. uh, it was the first time when I had actually applied the knowledge gained from my studies to a real life scenario. And trust me, it was a really insightful, development for my further professional life. I hope that it'll also help you all to get gear of the professional career that you all have lying ahead. And so, all the best to all of you. Hope you all have an equally enthralling, challenging, and life changing experience. Thank you.
Thank you, Tanya. You surely are a force to be reckoned with. Thank you for spending time with us today and wishing you the best for all your future endeavors. I believe the finalists of today have actually posed a really difficult problem in front of our judges. So let's give them more of time to evaluate the entries. And meanwhile, we'll call for a short break. We'll be back in next 10 minutes. such firepower. Today has been an extremely high-octane day. Let's amp it up even more and have the jury come up on stage. May I please invite the jury members to come up on stage?
Hi, and I would like to first of all congratulate all the 10 people who have participated. They are all winners in their own right, and they have really showcased their talent and impressive presentations, all of them. And in fact, the analysis which they have done was amazing. And in fact, sometimes we look forward to such amazing talent and having with us in Tata Steel, given the objective of this program. So I congratulate each and every one of them. It was really wonderful experience for me. I got to learn a lot, and I'm sure hearing others, you guys have learned a lot. And we do believe that such initiatives will find encouragement all across the universities, and it will find word of mouth with your friends, colleagues, and about Tata Steel. So I look forward to engaging with you again and interacting with you in whichever forum this comes up. And thank you for being with us and participating in this program. It was really wonderful, and best wishes for the results.
Thank you so much, Prabhat sir. Sundar sir, we know that students have already presented their presentation. So we would like to know, what do you think out of all the presentations that have come up today?
Yeah, thank you, Urvashi. As my colleague Prabhat has mentioned, for me, it's really a unique experience, because because I was also a bit surprised when I was briefed initially that they were in the second year of engineering they completed. Because generally we do have tendency to compare yourselves when you come across such bright young engineers. So absolutely no comparison. The way we were in second year, the understanding we had, and the way I have seen them, the breadth of the problem which they understood, and the way they gave solution, and also when we ask them some of the queries, and sometimes we ask because of our ignorance also, we wanted to know, the way the responses we got really good. Absolutely, I see, unless you have passion and also the eagerness to excel in the area, you won't be able to come up to that level of understanding and analysis to the depth which I had seen. So my congratulations to all the participants, because coming to this level out of 950,000, coming to the best 10 is not a small thing. Seriously, you have put in all the efforts. And the way I mentioned, we would like to, by the way Prabhat also mentioned, by word of mouth, we would like to have more and more participants going forward. This is season 5 going forward, so that the way we wanted to have the good representation, fair representation of our female employees in Tata Steel. This is one big and good forum where we can address. And my compliments to all of you, and best wishes to the first 3 who are going to be announced. And don't get disheartened, because really we had a tough time in deciding who is 1 and who is 2. It's only number game, but as if you ask me, I would put all 10 on number 1. But since there is a criterion, that's why I'm going by that. But my best wishes to all of you, and definitely I look forward to meeting all of you once you join the organization. Thank you, and best wishes.
Thank you so much for the feedback, sir. I also do believe that every participant in itself is a winner, because if you are participating, that itself is a big task. And it is actually through such insights that come from you that the participants will become even stronger forces that the world will reckon with. Okay, with this, we'd like to hear out sir who has sailed through with flying colors today. Can you please do the honors and announce the second runner-up of Tata Steel Women of Metal?
So the second runner-up for the entire 5th season of grand finale is Khushbu Puntal.
Congratulations, Khushbu.
Thank you, ma'am. Thank you, sir. Thanks, everyone.
Congratulations, Khushbu.
Thank you so much, sir.
Now it's time to know the first runner-up of the competition. So can you please do the honors?
Yeah, Prabhat.
Yeah. So I'm happy to announce that the first runner-up is Mridula Venkat Narayanan from NIT Trichy. Congratulations, and really happy to see that.
Congratulations, Mridula.
Thank you so much, sir.
Congratulations, Mridula, and best wishes.
Thank you so much, sir.
And it's time to know the winner of this grand finale. So I would like both of you to please announce the name of the winner.
No, Prabhat, please go ahead.
No, very happy to announce, and it is really a pleasure on behalf of Tata Steel and everyone in Tata Steel, and especially all the participating members today and who have participated. I'm very happy to announce the winner, Aishwarya Rai, Raj,
yeah.
Raj, IIST Shipur. Congratulations, Aishwarya, and really congratulations from the entire Tata Steel team.
Thank you so much, sir. Thank you so much. Words to express my feelings. So all my family members are jumping with joy, sir. Thank you so much. Thank you. Thank you very much.
Congratulations, Aishwarya, and all the very best.
Congratulations, Aishwarya. Aishwarya, Mridula, and Khushbu, and we didn't realize that, yes, your family members would also be excited to know the results. So congratulations to them also, and all 10 participants. My special thanks to all your parents and all family members, because I could see I had taken time to go through the background of each one of you. And I know the way they were passionate enough and they wanted to bring in excellence in you people. That has come up very well, and I could see on the screen all of you. So it's good. My best wishes. Once more, let me tell you, please, the other 7, please don't get disheartened. It is just one of the things in the entire career and life of all of us. Take it in very sportively, and as I mentioned, it was a tough call for us also. It was only a matter of 1 or 2 points here and there. Else all of you did wonderfully well, and also beyond my expectations. At least when I see last 31 years of my career in Tata Steel, this is one of the best experiences I had got by interacting with you and also going through the presentations. And once again, thank you, and all the best to all of you.
I would like to also take this opportunity to thank, and I think the real architects of the leaders of tomorrow, which all Aishwarya in particular and the winners in particular, and everybody who has participated in this contest. And I really thank their parents and everyone who encouraged them. And they are the leaders of tomorrow. And that's what I would like to see them grow, budding wherever you go for your future. I can see that you are the leaders. So congratulations and all the best, and look forward to engaging with you in the coming times.
Thank you so much, sir, for your such valuable words. Thank you so much, sir.
Thank you so much, sir.
Congratulations to all the winners and to the participants as well. May I please call upon Ms. Divyangana to deliver the word of thanks.
Hi, everyone. So on behalf of Tata Steel family, I take this opportunity to propose a word of thanks to everyone who contributed to this season of Women of Metal. So at the outset, I thank our jury members, Sundar sir and Prabhat sir. We are really enlightened by your knowledge and presence to grace this occasion. And thanks to all the students for active participation and sharing their innovative solutions towards the cases that were given to you. And congratulations to all, and special thanks to the organizing team. Thanks everyone, and all the best.
Thank you so much, Divyangana.
Thank you. Thank you.
Thank you.